Hello everyone and welcome back to my YouTube channel. Hope you guys are doing great. So I received a couple of requests in order to cover a end-to-end rack project, that too using Azure cloud resources and using a modular coding. So I have put in a lot of my efforts in order to come up with this project where we are building an AI power investor intelligence platform. So it is a RAG based project, and we are going to build this particular project from scratch. We are going to develop it, and at the end we are going to focus on deploying this particular project as well. So we'll be deploying this project on the Kubernetes cluster. So this is a complete package. This video is going to be little longer, so I'm thinking to cover this video in parts. Yeah, so in this part, I'm going to give the application demonstration, how the end application is going to look like. So without wasting time, let me take you to the demo. Okay, so this is our user interface. You can see AI powered investor intelligence platform. So what exactly this particular application does, it compares the annual reports of the organizations, and based on that it retrieves some of the KPIs out of it and it shows those KPIs for the end user. Now our end user for this application are the investors who are who are willing to invest into these organizations. So what they can do, they can download the annual report of the company that they want to invest, and they can upload the report to the application, and once they upload the report, it will go ahead and extract the KPIs out of that. KPIs like revenue, then it's going to extract the net income, income, total liabilities, total assets, cash flow, all those details it is going to extract along with the total growth drivers, then top risk factors. It is going to extract these KPIs, and based on that, the investor can take a decision whether to invest in the that particular company or not. So this application is helpful for the investors. Now, as you can see on the left side, we have this iTech. So I would highly recommend please go ahead and like the video and subscribe to my YouTube channel, because to come up with this end-to-end video, it takes a lot of effort, a lot of things that I need to prepare. Also, there is a cost involved. I need to pay for the cloud resources that I'm using. So please go ahead and like the video and subscribe to the YouTube channel. So the application starts by uploading the annual report. So you can click on annual report upload, and then you can select the report. So I'm selecting the report for Tesla because for Apple and Microsoft I already done that. So let's select 2024 Tesla report. So here the reports are pretty older, but these are just the sample reports. But yeah, actual investor can go ahead and use the actual reports. So you can see now the uploading the report is going on, meaning it is uploading the data to the vector store. But before that, it performs several steps. So the first step involved is, first it is going ahead and retrieving the content out of that particular document. So it is PDF format, so it is retrieving that into the text format, or it is retrieving that and converting that into the markdown format. Now why markdown format? Because it is the most suitable format that is used while feeding the information to the large language model, because markdown format preserves your table and other structure, and in these documents we have a lot of tabular information available. So let me quickly show you one of the report. But before that, if you see now, the upload has been completed, and you can see the Tesla report has started populating here. And you can see along with the other KPIs, now it is showcasing the KPIs for Tesla as well. So let me quickly show you what report that we have submitted. So this is the report, United States Securities and Exchange Commission. This is for Tesla. And in the below, if you see, it has a lot of information available. The PDF is pretty long. It has 144 pages. So if I scroll down and I'll show you, there are information available. So if you see, we have tabular information available with respect to the total deferred, with respect to the different matrices that we are extracting, the taxes and all other information. So converting this document to the markdown format helps us preserve this particular structure. If you are converting this into the text, it is going to basically hamper this particular structure. It will simply store that data into the TXT format, and you will lose this structure information. And this structure information is helpful whenever we are performing the chunking. So once this particular conversion of PDF to markdown format is done, then we perform a semantic chunking. And for semantic chunking, we have used a Azure OpenAI text embedding model, a medium model. And again, in the whenever we are building the project, I'll show you how to deploy those models and everything. So with the help of that model, we have basically converted all these documents into a semantic chunks, because you can see the PDF is 144 pages long. That PDF we have chunked it into the semantic chunks, into small chunks, and those chunks then we have ingested it into the vector store. And for vector store, we have used Azure AI search. So let me quickly show you the Azure vector store that we are using. So this is the vector store that we have created, and if I go to the indexes, So we have created this index, and you can see too many documents we have updated. And if I'm searching Apple here, let's say, or let's search Tesla, so it will extract the details related to the Tesla. So if you see, it is extracting the details related to the Tesla. So this is the vector store, which is whatever information that you have chunked, it has updated that information into the vector store. Now coming back, so once that ingestion into the vector store is done, then we hit several queries. Now what queries? In order to retrieve the revenue, net income, the operating cash flow and all those details, we have defined several queries. We hit those queries to the vector store, and out of which we retrieve this content related to these KPIs. So for revenue, we are retrieving the content from the for the Tesla, and that content then we are passing it to the GPT-5 model. So GPT-5 is a LLM. Again, we are using Azure OpenAI in order to we are deploying the model on Azure OpenAI and utilizing that model. So this retrieval, we feed it to the GPT-5 model. GPT-5 model then generates the output in the structure format, in the JSON format basically, and then that JSON format, then we ingest it into the database. So database we have used here is the Azure PostgreSQL, which is a structured database that we have used in order to store the KPIs. So if you see currently on the financial metrics table, we have these information available for Apple and Microsoft. Ignore the duplicates because I tried uploading multiple times the document because I uploaded the same document multiple times. So there are duplicates, but currently Tesla is not there. So if I execute this, you will see the Tesla document as well. So if you see, Tesla document is also has been added. Meaning what it does is whatever KPIs that we are whatever KPIs that we want to showcase on the dashboard, it retrieves the GPT-5 model, extract those KPIs from the content that is retrieved from the vector store, and that KPIs then it ingested into the PostgreSQL, and from PostgreSQL the user interface keeps serving those KPIs on the keep serving those KPIs for the user. So this way, what happens is you are only extracting these KPIs at once. So you are thinking from the cost saving perspective. You are not always going ahead, and whenever user is refreshing this application, you are not again hitting the queries to the vector store and retrieving the details, because it's a costly operation. Instead, you are storing them into the vector store. Storing them into the PostgreSQL. So that's how we have thought from saving the cost perspective as well, and we have thought from how exactly we build the application in the industry. Now, once this part is done, uh, like we are showing these KPIs, but there is one more interesting part available for this application. On the right side is the AI analyst chatbot. So just like actual industries, like nowadays industries are not only focused on building the chatbots, they have moved away from chatbots, and now they want to build an interactive dashboards like this with the help of AI capabilities, where they want such kind of dynamic dashboards which will help the business. So along with the chatbot, this is how we have tried to build the dashboard. Now the functionality of chatbot is for again the investors, where investor can ask follow-up questions on the metrics that they can see on the dashboard. So for example, let's say I'm selecting company Apple, and this particular result is for fiscal year 2024 Apple. So let's go ahead and ask the follow-up question. Please tell me more about the increased max sales driven by higher laptops. Now in this case, what will happen again, this particular query will be hit to the vector store. From there it will retrieve the content. That content it will pass to the GPT-5 model, and GPT-5 model will generate the response in the human readable format. So this is how it is generated based on the provided 2024 data. So this is how the increased max sales was driven by the laptop sales. So it is extracting the details of the sales obtained from the Mac laptops. So that's how this particular AI analyst chatbot is helping the investor to answer their follow-up queries if they have any, and these particular dashboards are helping them to understand where they can focus on investing by comparing these particular revenues and net incomes and the EPTA and everything against multiple organizations. So that's how I have tried to mimic exact real-time industry applications. And trust me, guys, I have put in a lot of efforts in building this application. So if you have liked this particular video, please go ahead and like the video, subscribe to YouTube channel. Please give a thumbs up for my efforts, whatever I'm putting in order to come up with this particular end-to-end project. And as I mentioned at the start, this is going to be a little longer series because we are now covering everything as per the standard industry practices. So in the upcoming video, I'm going to sit with you and we are going to build an architecture as well. We'll define the architecture, and based on that architecture, we'll start coding. Once the coding is done, then we will go ahead and deploy the application on the Kubernetes cluster. So whole thing we are going to cover as part of this series. Now, in today's video, we are going to focus on the BRD, that is business requirement document, and then we are also going to see the project architecture, both logical architecture as well as the physical architecture. So let's get started. So as I mentioned earlier, BRD is a business requirement document. Now the project name, we have received it from the business, that this should be the project name. Now let's understand what's the business overview. So the AI-powered investor intelligence platform is designed to help investors and analysts to quickly understand the financial health and performance of a company by analyzing their annual reports and financial statement. So in the last video, I showcased the annual reports of Tesla. So that's what the documents that we are going to receive it from the business, and those documents contains the financial statement information, the annual reports of the companies. So that particular information, with the help of our platform, is going to transform these lengthy financial documents into easily consumable business insights and dashboards and conversational responses, enabling faster and more informed decision making. So this is what is the requirement. This is the business overview. Let's understand what problem the business is currently facing. So the challenge is that the user currently spends significant effort manually reviewing the reports to understand these KPIs like revenue performance, profitability, financial positions, business risk, growth. All those details currently the investors and financial analysts, they do it manually. They spend a lot of manual time. They spend a lot of time in reviewing those documents. And what they want is a faster and more efficient approach to extract these present KPIs and insights. And that is what is our business objective. The platform should simplify the analysis of annual reports. It should reduce the manual effort required to review the financial document. Then it should automatically identify the key metrics like the total revenue, EBITDA, and other metrics that we saw in the last video. It should highlight the business risk and growth opportunities, present information through an intuitive dashboard. So we need to build we need to build a dashboard accessible to the end user, and which enables user to ask follow-up questions and receive a contextual responses. So that's where we need to build an chatbot as well, where user can ask the follow-up question. And that's how it should improve the accessibility to the financial insights. So that's the business requirement. And let's understand the functional requirement. So user should be able to upload the document currently are in the PDF format. Then automated insight generation, it should generate and extract the KPIs that the business has suggested. So what are the KPIs? Like it should identify the revenue, net income, operating income, cash flow, total asset, total liabilities. These KPIs it should extract, and it should generate a business insights on top of that, and it should provide a key risk factor, growth drivers, the executive level financial summaries. So with the help of these information, it is going to give a brief idea for the investors or financial analyst how the company is performing and whether should we take a decision to invest into that organization or not. And again, the one more request is that a interactive AI assistant, we should have an AI assistant where user should be able to ask questions in natural language. And they have given some questions like, okay, why did revenue increase in 2024? What are the major risks highlighted in the report? So they should be able to ask these follow-up questions. So we will have to build an AI assistant as well. And the last one is the dashboard, where we should show all the financial metrics. So expected business value out of this project is the platform enables investor and analysts to reduce the time spent in reviewing the financial document. So it should reduce the time of analyzing these documents, as well as it should reduce the manual efforts. And by automating the document analysis, providing conversational access to information, and presenting insights in a structured dashboard format, the solution supports a faster decision making and improved productivity and better overall user experience. So with the help of this application, we are not only reducing the manual efforts, we are saving their time, as well as we are providing a better user experience. So those are the business value that is expected out of this project. So this is how this is one of the format in which we receive the business requirement, and we call it as BRD. So this is not the only format. Again, in some cases, the business may give lot of details. At in this case, they have given high level information, what is their expectation. Now in the business requirement document, you might have noticed that they have not shared any information how you are going to build this particular application, which technologies you are going to select, which cloud service you are going to use, because business doesn't care whatever technologies that you want to use. They want what they want is the application should be able to serve the purpose whatever is mentioned in the business requirement document. So we have a freedom to choose the technologies, but yeah, again, we need to review those selected technologies with the architecture team present in our organization. So that is one more process where we need to prepare first the architecture diagrams, and then we need to discuss those architecture diagram with the architecture board. Well, they will approve it, and once they approve, then you can start working on creating those services. So without wasting time, let's straight jump onto the architecture. Okay, so first of all, this is our logical architecture. So whenever we build architecture, there are two types. First one is the logical architecture, which shows the logical flow, how uh, the user is going to ask the questions and how it is going to navigate across these multiple services that we are going to create, and what are the process blocks that are available. That is what is represented in the logical architecture. And in the physical architecture, we actually show the physical services that we'll be using, like the Azure Kubernetes service that we are using, container registry that we'll be using, the PostgreSQL that we'll be using. So where we will show all those physical entities. So first, let's understand the logical architecture. So I already talked about this particular process in the last video, but I didn't show this particular architecture. So let's review the architecture now. So as you can see, user asks the questions, which is in the format of query. But before that, let me show you the user interface, how it looks like, in case if you have missed the last video. So this is our user interface. This is what we are going to build at the end of this particular series, where we have the ingestion report, where we have a feasibility to upload the reports. And here we are having the AI-powered investor intelligence platform KPIs. So these KPIs users can review. And at the right side, we have the chatbot. Okay, so the user can interact with the user interface. So whatever dashboard that we have built, and these are the three options available. First one is the ingest report, where user can ingest the report. Second, user can view the KPIs, and third, user can start a user can start interacting with the chatbot. Now, whenever user ingest any new report, that report, first of all, it is in the format of PDF. That's what we are allowing it. Now, this is the complete RAG operation in the dotted line, whatever you see. First step is converting these PDFs into the Markdown format. So in the last video, I already mentioned why the Markdown format conversion is required, because it maintains your structured data, whatever is available in your PDF, let's say the tabular information. So it maintains that tabular structure as is in the Markdown format, and which becomes easy for us to ingest that into the large language models. Once that conversion is done, then we pass that to the semantic chunking. Now in the semantic chunking, what happens is we use a embedding model in order to do the semantic chunking. Now, how exactly the semantic chunking works, I'll talk about that whenever we'll actually build this particular semantic chunking. So basically we convert the extracted text into the vectors, and then we find out the similarity across the vectors, and based on that we perform a semantic chunking. But we are going to see that in depth. And for that, we are using Azure OpenAI. So from Azure OpenAI, we are importing a text embedding model. And with the help of that model, we are performing a semantic chunking. Then the flow goes to the vector store. Whatever chunking information that we have, we store that into the vector store. And here we have used Azure AI Search as a vector store. And in the last video, I showcased this vector store as well. From this particular vector store, so we basically extract these information. So we have a extractor module which extracts the information. Now this information like revenue, net income, these are the KPI information. So we extract this KPI information out of this vector store, and for that we hit several queries related to the revenue. We hit the query then related to the net income. So we have standard queries written. We hit those queries to the Azure AI Search, out of which we extract the content related to these particular KPIs, and we pass that content to again a GPT-5 model, which is our ELLM. Now this ELLM is a GPT-5 model again, which is hosted on the Microsoft Foundry, and out of this particular model, it is having a capability to generate the structure output. So whatever content that is retrieved out of this particular vector store, it will be converted into the structural format. In the structural format, it will be converted into the JSON objects like revenue and its value, then net income, its value, something like that. And then that information, we store it into the PostgreSQL. Again, we have a Azure PostgreSQL, which is a flexible server that we have created. These KPIs we extract and pass it into the vector, into the SQL database, because That way you no need to keep retrieving these matrices again and again. So for one time you are retrieving the matrices, and then you are ingesting that data into the SQL database, and from that SQL database that data goes to the user interface. So on the UI dashboard, whenever user refreshes the screen, it pulls the latest information from PostgreSQL instead of hitting the query back to the vector store and then passing it to the LLM. So we are doing a cost saving operation. Here first cost involved is the hitting to the vector store, so the retrieval cost. Second one is the passing to the GPT to extract the KPIs out of it. So we are saving that two instances of hitting to the AI services, and the user interface can directly pull the information from the SQL database. So that is the RAG operation that we perform whenever we ingest the report. Now there is another platform, that is chat interface, AI assistant. Now whenever user asks any questions to the AI assistant, what happens? First it hits to the vector store. From vector store it retrieves the relevant content with respect to the user query, and then it passes that retrieval again to the GPT-5 model. GPT-5 model then again generate the output, but this output is not in the structured format. Instead it directly passes that output to the chat interface, which is in the format of a natural language text, right? So that's how the natural language text that the user is asking over a chat interface will be hit to the vector store. The retrieval operation is done. Then we are going to augment that response, and the GPT-5 is going to generate the final output, which is going to be sent to the user interface. So that's how the complete logical architecture that we have built. So this is exactly similar to the actual industry project. So we have mimic all the components exactly as is. So this, so that's all about the logical architecture. Now let's move one step ahead and let's understand the physical architecture. So as I mentioned earlier, logical architecture only shows the flow, how the information is going to flow, right? But physical architecture actually talks about the physical entities that we are going to use. So this is our physical architecture. So if you see physical architecture, okay. So the user on our application is the investor and financial analyst, which are going to interact with our user interface. And they can perform these tasks. They can upload the annual report, they can view insights, they can view the dashboard insights, they can chat with an AI assistant. And these are the activities they can interact on the user interface. And once they start interacting with the user interface, an HTTPS request goes back to the microservice. Now we have created single microservice for backend and UI. Again, not a wise choice. In actual industry, we select separate microservices for backend and another for UI. And the reason, if any microservices goes down, so if anything wrong happens to any microservice, only that microservice service goes down. So, and again, it is easy to debug as well. That's the reason we keep separate microservices. But in order to save the cost for this particular project, I have combined both. And again, if I create two different microservices, we'll have to work on deployment of those two microservices. And in order to keep it simple, currently we have kept one microservice, but yeah, in the upcoming projects, right, I can cover the multiple microservice deployment as well. And on the investment, and then this is our investor intelligence platform, where which we have built it using the fast API and HTML, CSS. Then we have a AKS, which is a Azure Kubernetes service. So with the help of AKS, we are going to deploy this microservice. And AKS is basically a managed service by the Azure, which helps us manage the deployment. Manage the deployment in the sense, whatever cloud resources or whatever compute resources that you required in order to serve this particular service is going to be managed by this AKS. So all the load balancers and everything is managed by this AKS. So if in case on your application, if load is going to increase, this AKS service is going to manage that. It is going to scale your pod. Again, this is not a deployment session. So once the time comes for the deployment, in that video, I'll cover in depth how this particular AKS service works. Azure Container Registry is basically where we can store our Docker, where we can deploy our Docker file. And again, what Docker files and everything, we will talk about it once we start the deployment part of this particular application. Now, once the request comes to the backend, then backend interacts with the fellow services that are connected to it. So the request goes to the Azure OpenAI services from the backend, then request goes to the Azure AI services, request goes to the Azure PostgreSQL services. So based on the requirement, based on the action that user is taking, these particular backend services are giving a call, the REST API, HTTPS, it is hitting those calls to these particular services that we have deployed. And these OpenAI services, the Azure Cognitive Services, like the Azure AI Search and Azure OpenAI, are hosted on the Microsoft Foundry, which is a model hosting and management platform. We will talk about it again once we start building this particular application. And as you can see, this dotted line, which shows the one-time KPI extraction, the way we discussed, right? The thing that we discussed in the logical architecture diagram, this is one-time extraction of the KPIs, which will be stored into the vector store. So that's how the physical architecture looks like. And here you can see Azure non-production production subscription. Based on the subscription in which you are working on, we add this particular part, whether it is a non-production or production subscription. For us, it's going to be testing project. So we will create a subscription. I have already created one subscription and we'll be using those subscription in order to deploy these services. Now, this is not the complete physical architecture. There are too many details that are currently missing because we are not covering those details into this particular project. And I'll be very honest. Like, first of all, we are not converting the auth mechanism. So this user is directly accessing our application. There's no auth mechanism. So we should have enabled a SSO login, a single sign-on login, or username password login for this particular user. Currently, the application can be accessible by anyone. So that authentication is missing. So if you are adding the authentication, we need to change this HTTPS request with the secure request. Again, we have not mentioned for example, we have not mentioned any cache mechanism in between because this is again a simple project, not too many details available. So we can directly serve the user interface through the Azure PostgreSQL, and there is no need of using the Redis. Then monitoring systems are missing. Once your application is deployed, how you are going to monitor these services, whether these services are up and running, is there any issues going on with these services, the performance of those services, the application performance monitoring logs, everything we can capture it using the logging mechanisms. So those parts are missing. And from the security stand perspective, too many details are currently missing. But yeah, the goal of this particular project is to complete the end-to-end process, like how we can actually build the applications in the industry. Now, the security and other concerns, right, in the organization, there are multiple departments associated with it. So security is going to be taken care by the security team. The access and identity management will be taken care by the IAM team, that is identity and access management, how the user should access this particular application. So for that, we create AD groups and whatnot, right? So many details that are available, and we'll talk about those. I'll give you a high level idea whenever we'll build the project, but just to keep it simple, and again, just to save the cost, I'm covering the basic stuffs in the sense I'm covering in depth only, but the things that actually works in the industry, right, like the AD, Azure directory, right, active directory, we create a Azure active directory in order for the users to access the application. Now, the username and password based login, right, that is not widely used across industries. What industry follow is you should have a single sign-on. So that way you can enable your multi-factor authentication as well, and with the help of your email ID and password, you should be able to log into the system. So which gives the easy and feasible logging for the user. So those are the other parameters that are currently missing from this architecture. So this is this is a very basic architecture. Maybe sometime in future, whenever I'll cover these topics as well, right? Like if you are interested, just let me know in the comment section if you want to know about building and this architecture side as well. So we can basically cover these detailed explanations in separate videos, how these particular architecture diagrams we can draw, what are the tools we should use for drawing these particular architecture diagrams and whatnot, right? But yeah, so that's it for this particular video. We have covered the business requirement document, and then we have talked about the logical and physical architecture. Now, in the next step, we can actually start coding the application. And whenever we are coding the application, it's going to be again a long session. Maybe I'll split it into the multiple parts. But whenever we'll start on the coding session, we will be deploying these services side by side, like PostgreSQL, the Azure embedding services, AI services, embedding model, AI services, everything will be deployed whenever we'll work on the actual coding session. So don't miss that. So again, we are going to keep it very simple. I'll talk about what and all things that we have written in the code, and mostly we'll focus on the process instead of focusing on the coding aspect, right? So yeah, I hope this video was helpful for you, and I hope you are interested in building this end-to-end project along with me. So this is the part 3 of this series, and in the previous two parts we have covered the demonstration of the application in part 1, and in part 2 we have covered the physical and logical architecture and the basic overall project flow. Now if you have missed those two videos, I would highly recommend go ahead and check out those, because those are very important, and as per our goal, we are targeting to complete this end-to-end project. So we have started from very scratch, defining the problem statement, understanding the business requirement. Then accordingly, we have built the physical and logical architecture of this particular project. Now in this particular video, we are going to focus on coding this particular application, as well as we will be creating the cloud resources as and when required. So this is going to be again really interesting video. So please watch this particular video till the end. And if you have any questions, please feel free to drop them into the comment section below. So let's get started and let's straight jump onto the VS Code. Okay, so you will get the link of this particular code in the description below. So I have pushed this particular code to the repository along with the nodes. So you will get all the details, and I will keep updating this particular repository. So by end of this particular series, you will get everything that is required. And feel free to use this particular project into your resume. You can definitely explain this into your resume. And trust me guys, if you explain these kind of projects, because whatever we are covering, right, it is completely relevant to the industry. Like whatever we build in the real organizations, it's completely in line with that. So feel free to mention these projects into your resume. So let's get started, and you will get the codes and everything so that you can do the hands-on later on. Okay, so if you are not willing to code along with me, that's fine. You can sit back and relax and watch this particular video. But yeah, I would highly recommend pause this video, or while doing this, while watching this particular video, go ahead and practice this stuff, because once you practice, then only you will be able to understand this particular project flow. Okay, so again, in the era of AI assistants, we are not going to code this particular project line by line. So instead, what we'll be doing is we will, based on the flow that we have defined in the architecture. So this is our logical architecture and the physical architecture. So based on this particular flow, we are going to code this particular application. So let's get started. So the first step is report ingestion, and in that report ingestion, the first step is converting from PDF to Markdown. Now, PDF to Markdown meaning we have the data set. So if you expand the data sections, we have raw PDFs. So let me quickly show you one of the PDF. Okay, so if you see, this is a organization data, which is the annual report of Apple company. Now below, if you see, we have lot many details like the business related information, risk factor, then we have tax informations, the total sales and everything. So if you scroll down, you will get all those information. So if you see, we have total purchase information, then we have some trends, and again we have total net sales and all other information. So as part of this application, we need to extract these details and we need to show these details onto the dashboard, user interface dashboard. Like we need to show some KPIs like total revenue, then the cost, how many, what is the profit of the organizations, and all those details. Based on that, the investors will take a decision whether to invest into this organization or not. So yeah, this, all those things I have already explained in previous two videos. So if you have missed that, please go ahead and check out it. Now, coming back to the project, so I have maintained this particular file, project journey.markdown. In case you face any issues, you can refer to this file. Along with that, I am also adding the README. I am yet to add the instructions into the README, but I will add all the detailed instructions, what and all steps that you need to follow, what parameters that you need to set so that you can run this particular project in your local. And if you face any issues while executing this, please reach out to me and I'll definitely help you. Now, as this is the AI powered investor intelligence platform. So first step is we need to convert these annual reports into the Markdown. And I already mentioned why we need to convert this to the Markdown, because Markdown preserves the structural information available in the PDFs, like the table structures and other information. Now, for that, we have a folder called ingestion. So under ingestion, you will get the PY file, PDF to Markdown conversion .py. Now here, if you see, first of all, we have used this particular library PyMe PDF for LLM. Now, why PyMe PDF for LLM and why not normal PyMe PDF? Though our documents are digital documents, digital means we can directly extract the text. It is not the scan copies. But in order to convert to the Markdown, we are using this PyMe PDF for LLM because it helps maintain the structure of the data. Like we have the sales information available in the table. So whenever we will convert this file into the Markdown, it will make sure to maintain that structure as is. So we will execute this code. So first of all, let me delete whatever is there in the Markdown. So let's go ahead and delete it so that we'll be able to see this. Now, first thing is we need to create the virtual environment. That's the first step of every application. So let's, in the terminal, yeah, we'll be using UV as a Python package manager. So if you have not installed the UV, go ahead and install it. So the step is very simple, pip install UV. So with UV, it becomes very fast to install the dependencies and manage your virtual environments. So if you see, I'm on version 0.8.22. Now, in order to install the dependencies, first of all, you will have to create the requirements.txt, and under requirements.txt, so if you see, the first dependency that we have added is PyMe PDF for LLM. Now this PyMe PDF for LLM is going to help us convert all our PDFs into the Markdown. So let's install the dependencies first. UV pip install -r requirements.txt. Now we are installing all the dependencies in one go. Okay, you can see it is using Python 3.12. Make sure you are on Python 3.12 so that you will not face any issues. Now currently you will see the dependencies are like this. There is no exact versions added, but while pushing this particular, but at the end I will push the changes where I will add their exact versions that we have used, so that you will not face any issues while installing the dependencies. So okay, audited all the packages. All the packages have been installed. I think it was already there. Oh, I made one mistake, sorry. I did not create the virtual environment. So first of all, we'll have to create it. So the step is very simple. In order to create the virtual environment with UV, you just need to write UV, and when it will create the virtual environment. So if you see, it has created 3.12, used Python 3.12 and created this virtual environment. So if you see, the VNV is added there, and in order to activate it, you need to go to the scripts and you need to run this file activate. So let's go ahead and do that. So they have already given the command. Let's paste this command and hit enter. Okay. So the environment has been activated. Now we can go ahead and run the script to install the dependencies. Let me just clear the screen. Okay. Clear the terminal, and again let's hit the command uv pip install -r requirements.txt. Okay, you can see it is installing the dependencies. It will take some time, but yeah, it will be very fast. You can see too many requirements are there, but still it has installed all the requirements within a second. So that's the power of UV. Okay, now this part is done. Now let's move ahead. Go to the PDF to Markdown conversion. Still it is showing the import is not, could not be resolved because we have not selected the right environment, I believe. So okay, it is still showing here, but let's go ahead and select it once again. Interpreter path, find, and this is when you can go to the scripts and you can select Python. Okay, see, now it is referring to the latest environment. So let me do that for this as well. When scripts Python, okay, all set. Now it is, now the error has okay, now the error has gone. So in this code, what we are doing is, first we are converting the PDFs to Markdown format, and again we are using PyMe PDF for LLM. So if you see, it is, first of all, we are reading all the files that are available under raw folder. So that is what we are going to pass. So if you see PDF path, we are going to pass, and output directory, it will create a output folder in this particular data. Then it is using the encoding UTF-8 in order to convert it. And once the conversion is done, so this is for single file conversion. If you have single file conversion, you can use this. And if you have a directory, you can use this function. As we have a directory, so it will use this. So we just need to pass the input directory and output directory. So the code is pretty simple. So in order to execute that, we use this main function, which helps us execute this particular code or test this particular code. If you're not aware about the meaning of this, then please go ahead and check out that. It is pretty simple actually. Like, this code will be executed, this file or this particular lines after 64 will be executed only if you are running this file with Python PDF to markdown.py, then only it will be executed. If you are importing these modules into another file, let's say app.py, you are importing this PDF to Markdown, then it will not execute this code. It will only utilize these particular classes or functions that we have written. So that's the way. That's the benefit of adding this. Now this is quick thing that with which we can test the application. So let's, in order to run this, let's write Python. But yeah, first we'll have to go into the ingestion folder. So let's go into the ingestion and then Python PDF to markdown.py. Now this will create one folder here and it will convert all our PDFs into the Markdown format. So let's wait for that. Okay, you can see the Markdown folder is now available and it has converted first file. So let's go ahead and review this file. So if you open this file directly, you will not be able to understand pretty much. You will not be able to understand this, but in order to load the file, you can open it in preview mode. So in the preview, if you see, it has maintained the structure, all the details as is. So if you see table, it has maintained the tabular structure, whatever is available. Again, if you see this table of content, everything is maintained properly. And the thing that we saw right below the sales information, total sales. So if you see total net sales and everything. So it has preserved this particular content as is, the structure of the PDF. And now it is helpful for us to pass this Markdown format to the LLM. Okay, so that was the reason. Now, if you see the code has been executed and it has, sorry, basically converted all the files. Okay, now first part is done. So if we go back to our application, logical architecture. So if you see this part is done, converting from PDF to Markdown. This part we are going to build at the end because first we will complete the backend part. This backend part we will complete first. Once the backend is ready, we will connect it to the user interface, right? So once this part is done, now the next part is semantic chunking. So let's work on the semantic chunking. The first thing is we need to deploy these embedding models from the Azure OpenAI. So we need to do that setup. And for semantic chunking, we'll be using an LangChain. There are some classes available in LangChain, which with the help of which it becomes easy to chunk the data, semantically chunk the data. So let's go ahead and do that first. And I'll explain how this chunking is helpful and how exactly what happens behind the scene whenever we are chunking the data. So under this particular, sorry, let me close all these things. Now under this particular ingestion, we have this another file semantic chunker.py. And again, if you see, we are importing the document class from LangChain core.documents and we are importing a semantic chunker from LangChain experimental.textsplitter. This helps us chunk the data semantically. And with this, it uses a large language model for doing the semantic chunking. Because it is a semantic chunking, right? Now there are two ways with which you can chunk. You can directly chunk the data or use semantic chunk. Directly in the sense, you can decide the fixed length of the text on which you can directly chunk based on your model context window, or you can use a semantic chunker. Just hold on for a bit. I will explain how exactly that happens, or let me explain that for now. So then we can come to the code. So, okay. So in this semantic chunking, we are using embedding model and Azure OpenAI. So why the embedding model is required for chunking? Let's understand that. So let me take you to the, so here I have explained why the semantic chunking and how exactly semantic chunking works. So first, if you see, what we have is this kind of information we have. Like we have paragraph 1, which is related to the Tesla revenue. Paragraph 2 is related to the increase, the sales, increase in the sales. Paragraph 3 talks about operating margin. Then paragraph 4 talks about risk factor. Paragraph 5 talks about the future growth. Likewise, we have multiple paragraphs available in one document. Now, it is impossible to feed all these documents in one go to the large language model because of the context window limitations. That's where we need to do the chunking. Now, in the traditional chunking, if we chunk directly based on the fixed width, what will happen is that if you see, in the chunk 1, you will get paragraph 1, paragraph 2. Let's say the paragraph 1 and 2 is equivalent to the length, let's say, uh, equivalent to the length, let's say 1000 character, and your model, for example, supports only 800 character. Sorry, and your model supports, let's say, 1200 characters. So in that case, what will happen? It will create these two into one chunk because it is still less than the 1200 characters. That is the context window of the model, and based on that, it will create these two, create this chunk. Now, in this case, what will happen? It will chunk the data based on paragraphs, or it may chunk the data abruptly, like it will take the full paragraph 1 and half of the second paragraph. In that case, what will happen? Your data will not be chunked based on the paragraphs or based on the semantic similarity. It will be abruptly chunked. And the limitation of that, whenever we are feeding this particular data to the model, then you are losing the context, right? Context or meaning of this particular, semantic meaning of this particular paragraph. So that's how the traditional chunking works. Now in the semantic chunking, what happens if you use semantic chunking? First, we are using an embedding model. The task of embedding model is to convert our text data into the embedding or semantic vector. So in the semantic chunking, first, let's say the paragraph, it will create the embedding vector out of that. For second paragraph, it will create the embedding vector. Similarly, it will create the embedding vector for all the paragraphs that are available. And now the embedding vectors will look like this. Let's say for P1, the embedding vector is this. For P2, it is this. Like this, it will convert those paragraphs, text paragraphs into the embedding vectors. Now these embedding vectors, we will be utilizing a Azure OpenAI text embedding model. With the help of text embedding model, it will convert these paragraphs into semantic vector. Now these vectors are semantic. Now on top of this, we will perform a similarity activity. Similarity activity, how exactly it will be performed? Let's say P1, we will compare it with P2 and then we will identify the score. Let's say P1 and P2, if they are relevant to each other, we will find their cosine similarity. Let's say the score comes as 0.95, meaning 95% these two vectors are similar. So in that case, we will combine these two. We will again move further. We will compare P1 with P3, and if the semantic similarity is 0.88, we will consider P1, P2, P3 together. And if the P4, if we compare P1 with P4, let's say, and if the semantic similarity comes as 0.22, meaning, okay, P1 and P4 are not related because there is a big drop. In that case, you will create a boundary and you will not include P4 into the semantic similarity, first vector of semantic similarity, first chunk of semantic similarity. So that's how the chunking is done. Again, while doing this chunking, again, it takes care of the context window as well, and it makes sure that it is not exceeding the context window. So that's how the semantic chunking is done behind the scene, and that's the reason we need the embedding model. And in the embedding model, again, we are not using this embedding model in order to embed the input query because there are two algorithms in order to extract the query in the RAG operation. First one is the keyword search and second one is the semantic or vector base. And there is third approach, which is hybrid, which combines both. In my previous videos on my channel, I have covered the approach with respect to the vector. Also, I have covered the approach with respect to the hybrid. So I thought to cover only the keyword search for now. Again, you can change that approach based on based on your need. But to keep it simple, currently we'll be using a keyword search, and I'll talk about that how exactly it is doing. So once this semantic similarity score is generated, then you can see the final chunking will be like this. Revenue, energy, and operating margin will be grouped together, and risk factor, disruptions, and the regulatory changes will be come under chunk 2. So that's how it will create a semantic chunking, meaning it will do the chunking based on the context available, semantic meaning of those context, and that's how it will chunk the data. So this is what we are coding in this particular part now. So let's go back, and if you see in under semantic chunking, so first thing is it is reading the markdown file that are available from this particular directory, whatever directory that we will pass. Then chunk markdown. So what it will create, it will generate a semantic chunks from the markdown, and for that, if you see, it is using semantic chunker from LangChain. So this is what is the class available in LangChain. What it does, it splits the text based on semantic similarity, and for semantic similarity, it uses a LLM. Not LLM, sorry, it uses the embedding model. And for the semantic identification, it needs an embedding. So if you see, it needs embedding, and these embeddings will be created with the help of our OpenAI embedding model. So once we pass that, so if you see, it expects embedding and the threshold percentile, and then it is going to split it. But to pass this particular embedding, we will have to call the Azure OpenAI model. So if you see, from again LangChain OpenAI, we are importing this class Azure OpenAI embeddings so that we can pass this LLM capability. And these are the parameters that we need to set. These are the environment variables that we need to set into our environment file. So now I'll take you to the environment file .env. Again, there are multiple details available. You can ignore those. Let's focus on embedding. So first of all, we'll have to go ahead and import these details from our cloud resource. So for that, we need to deploy these particular models, embedding models, and from there we will get the OpenAI endpoint as well as the versions. So let's go to the Azure. Now, this is my Azure account. Now, if you don't have an active subscription, I would highly recommend go ahead and create one. Or if you have a free subscription, please use that. Again, I'm not covering how to create these Azure accounts and all because you will find a lot of videos available on it, and it's pretty simple. So create a subscription or use a free subscription. I'm not sure how free subscription will work because we have a large document. So maybe you will face some limitations while using the OpenAI models, Azure OpenAI models. Because on free subscription, there are limitations. Now, first thing that we need to go ahead and do is we need to deploy the Azure Microsoft Foundry. Sorry, earlier it was Azure Foundry. They have renamed it to Microsoft Foundry. So you can search Microsoft Foundry here and click on create resource. Now let's give the names. So we don't have any resource group. So let's create. RG stands for resource group and I'll give name as investor intelligence. Okay, it's available. And this name of the service, let's give it as investor intelligence. A region is used to, yes, that's fine. Okay, the domain is not available. So let me give AGF investor intelligence. AGF is Azure Foundry. Okay, which is available. Project is default, that's fine. Next. You can skip these details. Let's click on review and create. It will validate whether the names and everything that we have given is correct or not, or whether it is as per the requirement or not. Okay, so validation is done. Let's click on create. So this will go ahead and deploy the Azure Foundry service for us. So let's wait for this deployment. Okay, so the service has been created. Let's go to the service and let's launch the Foundry portal. So you can click on go to Foundry portal. Okay, now under the Foundry, you can go to the models and endpoints, and here we can deploy the model. So click on model, base model, and here you can search text embedding. There were 3 models available from the text embedding from OpenAI. Okay, so if you see 3 models are available, out of which we will go ahead and use the medium one because we have a pretty large PDF. So let's use this. Large is again, it will again incur cost. So let's go ahead and select this suitable one. Click on confirm and then it will ask us to customize it. So let's click on customize and token limit. Let me make it 150 and let's click on deploy. Okay, so the text embedding model deployment is almost done now. And okay, so we will get this key information. So you can copy this key and you can come to the application in the .env. You can replace this key with that key, whatever we have generated. Now, I know these secrets are exposed over this video now, but I'm going to delete the resources that I'm creating before uploading this video. So you'll not be able to use these keys, unfortunately. Make sure you use your own keys. Apart from that, what we will need is this deployment version. So if you see at the end, we have API version 2023-05-15. So 2023-05-15, which I have already added. This is the embedding model version. Endpoint, you can get the endpoint by going to the overview. And here select Azure OpenAI, not Microsoft Foundry, because that's what we are using with the help of LangChain. So let's use this endpoint. Okay, so we have added the endpoint. Let's save it. And then in the semantic chunker now, this is the model name. So you no need to pass the model name. So first of all, what it will do is, as this is for the testing purpose, it will use the file. So let me pass one file, let's say this one. Okay. So from data folder, we will pick this 2024 Apple Markdown file, and for which we will run this chunking. And we'll see how the chunking looks like. So let's go ahead and run this Python semantic chunker.py. Let's see if there are any issues, we'll fix it. Okay, ignore the warnings, that's fine. So this chunking and everything will happen dynamically once user uploads the file. In the backend, it will call these APIs in order to perform the chunking first and upload that data to the vector store. So just for your understanding, I'm showcasing this step by step. In chunking, what actually happens behind the scenes. So we have already understood the logic. We have already understood the phenomena, how the semantic chunking works. Now we will actually see the chunks that are created after this particular processing this particular document. So as the document is pretty long, it may create 20, 50 chunks So let's see how much it is creating, and definitely it's going to take time. And again, this incurs a lot of cost as well. So at the end, I will talk about how much cost it incur me. But yeah, please, if you are creating a subscription, make sure you are deleting your services once you are done with your usage, and be mindful while calling these services. Don't pass the complete data as is. Like now the files that we have, again, it has close to 100 or 140 pages in the PDF, so it is definitely going to incur a lot of cost. So please be mindful whenever you are working on this. And if you are worried about cost, I would recommend go ahead and slice the data. Out of those PDFs, keep only 5 to 10 pages, and then you can try it out. Okay, so if you see the chunks that it has created, so the first chunk is related to the annual report and all that information. The second chunk is, again, it has created. The third chunk, if you see now, the chunks are of dissimilar size, meaning this chunk is this chunk is not too big, because it identifies the semantic information. If only this semantic informations are available, then it will only keep it. So if you see, it is related to the indicator, so it is indicating. Then this one is related to, I believe, company's office portfolio, company operates various, the company's cloud, so company information. So that's how it has created the chunks. Now this complete data is created into 23 chunks, as I mentioned earlier, right? Because the document is pretty big and we are only printing top 3 chunks. Now these chunks are the semantic chunker. So based on the semantic chunking method that we saw, it is doing this chunking. Now this part is done. Now the next part is we need to ingest this semantic chunks into the vector store, and for that we need to create the vector store. So if we go back to the diagram again, so this semantic chunking is done. Now the next part is creating the vector store, which is our Azure AI search, the cloud service from the Azure to keep your embeddings. And we will use this vector store in order to serve the user interface later on. So one thing I missed to cover is how this, yeah. And once this vector store is done, then we will see how the extraction will happen, how we are going to extract these KPI information. So first of all, let's go ahead and create this service. So again, I'm going back to my service, and now we have created the resource group as well. So let's click on Azure AI search, and let's click on create. Here we will select the existing resource group RG inventory intelligence, and here we will give name as, let's say, AIS intelligence. Let's see if it is available. It's available, and you can go to the pricing and change the pricing if required. Now the free service is also available. You can utilize that. I'm going ahead with the basics one because again I'm having a big data. If you are chunking the data, select the free one. So I'm selecting it, review and create, it will create it. Now with this, I'm getting 15 GB partition memory, max 3 replicas, meaning the complete data will be partitioned first and it will be maintained into 3 different replicas, meaning there will be 3 instances created for each of the data. So this is required in order to speed up your serving activity. Meaning, let's say if 100 users are coming and retrieving the data. So in that case, let's say one replica may be sufficient. You can serve that. But what if 200 users are coming and you are facing load on your application? So in that case, load on your service. So in that case, it will retrieve the information from the surrounding replica, from the another replica that it has created, so that it manages the flow. Okay, let's go ahead and create it. Manages the flow in the sense it helps us better serve the application. So that's the reason it creates the replicas. And again, these replicas and everything is very important once you build the high scaled applications. Once your user persona, once your user repository is pretty big, you have thousands of users accessing the application, then in those cases it is helpful. Okay, the service is created. Let's go to that service. And in the indexes, currently we don't have an index. So if you see, the index is empty, and we can get the information from the security and networking. Click on the keys. First of all, let's copy this key because that's what we need to pass it. So if you go to the ingestion documents, and if you scroll down, you will see what we need is Azure OpenAI model that is required in order to perform this embedding. Then you need search endpoints. So again, go back to your environment and we need to pass these details. So search API key, let's replace this key with the one that we created. Next, go to overview and you can copy this. I think it's going to remain same because I created with same name. Okay. And the Azure index name, you can give it as financial document, you can keep it as is. And already we have given the embedding model name and embedding endpoints and everything, so we no need to pass anything related to that. Now, once we execute this particular code, ingestion code, what will happen? First, it will create the embeddings. It will create a vector, the index, and into that index, it will ingest this particular data. And in which format it will ingest, let me show you that. So first is parse a company year. So first of all, it is extracting the company name and year from the file. So make sure you use this file name like 2024 and Apple. So 2024 is going to be year and Apple is going to be company name. Again, you can change this method. You can use another method to identify that, because these two are the key parameters again, because we do some partitions on the UI. So it's for, we apply some filters on the UI. So it's for that purpose. Now, once we extract that details, then ingest document. So we need to pass the PDF path, embeddings, and vector store. Now in this, if you see, first we are reading the markdown file. We are performing the chunks out of it in the same way we saw in the semantic chunker. And then we are creating the vector store.upload. So with vector stores.upload, we are uploading this metadata. So let's go ahead and run this file, and then I'll show you what are things that it has uploaded. So let's save it, and let's run this file again, Python ingest documents.py. Let's go ahead and execute this. No module name ingestion. Okay. Let me check. Okay. It is saying no model name ingestion because we have not created a constructor here. So let's go ahead and create a new file and give the name as underscore underscore init underscore underscore dot py. This will make sure to mark this project, mark this particular folder as a module, and from here it will be able to load these particular modules like semantic chunkers and everything. It will be able to load. Okay, as we have created the constructor, so let's go ahead and run this. So in order to run this, we need to run it as a module. So first we need to go back to our main folder. So we are currently at this folder, AI powered investor intelligence, and here we need to run this as a module. So in order to run this as a module, we need to select -m, which stands for module, then ingestion, and then we, instead of forward slash, we need to use dot, and then after the dot we need to pass the file name, that is ingest documents, and we no need to give the extension .py. Just go ahead and execute this. Okay, so once we execute this, it will go ahead and run this particular file as a module. So it will be able to load all these data. So if you see, it is loading the Apple file. It has found 3 files and loading the Apple file. So I think we have only selected Apple file out of all the files that are available. Okay, it is ingesting everything from this particular raw. So what I will do, I will interrupt this once this particular ingestion is done for the first file, just in order to save the cost. Okay, generated 23 chunks for the Apple file. Again, it has generated the chunk because now we are calling the semantic chunk module here itself. There is one issue that we received. Financial documents for service AS was not found. Okay, let's see what's the issue. Let's go to the environment file. Endpoint we have changed, key we have changed, financial documents we have changed. Okay, one issue that we are getting is this particular index is not found. So what we need to do is we need to go ahead and create the index. So to create the index, I have written the code into the vector store. So if you see, if you expand the vector store, you will see Azure AI search.py and create index.py. So create index.py, what this file will do, this file will go ahead and create this particular fields, and it will create the searchable fields that are required while creating the index. So here we have defined the indexing format, and let's go ahead and execute this, and then I'll talk about this file. So let's go to vector store and here run Python create index.py. This will create the index, and I'll show you once the index is created. If you see, the financial index document index is created. So let's go ahead, go to the index, and let's refresh it. It should show the financial document. So if you see, it has created. Now under the fields, if you see, these are the fields it will be utilizing. First, it will utilize company, year, source file, content, and content vector. So if you see, these files are retrievable, filterable, and they are searchable as well. So content is searchable if you see. So whenever we will hit any query, it will search that into the content, right? Now let's go ahead and check that, the code. So in this code, if you see, we have already given these detail, simple field ID, and it is a key. Then if you see on the content, searchable equals to true, and on others, filterable equals to true. Meaning what we are doing is we are searching the content, whatever query that user will search. Let's say if user is searching for give me the total revenue for Apple, so it will search revenue for Apple into this content. It will retrieve that, and then these filterable fields are there. You can filter it based on apply filter based on company, that okay, user wants the detail only for Apple, so it will filter the details and it will only retrieve the queries that are related to the Apple. This is in order to improve the accuracy. So that's how it will go ahead and create the index. Now, in order to retrieve the data, we are using keyword search. How the keyword search works, let me explain that quickly. Okay. So we are using this particular algorithm BM25. What exactly is BM25? BM25 is best match 25. Now 25 is just the experimental number. After this trying this particular best match algorithm for 25 times, they obtain a good results on this particular experiment. That's where the name given BM25, which is best match 25. If you are interested, go ahead and check out the paper. I'll try to drop that link in the comment sections. In the description, you will go ahead and read about that. Now, for example, how it works is if we ask the question, what is total revenue, let's say. So in this case, what happens? First, it will retrieve the document, let's say document A, total revenue increased to 100 billion, and it has extracted the document, risk factors include inflation. User is asking this question, it has retrieved these two documents. Now document A is relevant, document B is not relevant. So then it will identify the score. Let's say for document 1, the score is 0.98, and for document B, the score is 0.1. So it will say that, okay, document A wins, meaning for this particular query, the right document to extract is document A. But how this BM25 works, it works on the principle of the count of words that are available. If you are aware about the TF-IDF process, term frequency and inverse document frequency, so it works on the principle of TF-IDF. Let's say it will first check how many times this total revenue is available. So what it will check first, it will take the word total revenue. It will check the total revenue is available in this particular document. It's not available in this document. So the count of total revenue occurrence in this document is higher than this document. So based on that, it will calculate the score, and that's how the document will be selected. No semantic similarity while doing the keyword search. It is doing a keyword based search. It will directly search the keywords. We use semantic search where we convert this particular vector into embedding. That vector then we pass, that vector then we compare it with the vectors available into our vector store, and then we calculate the semantic similarity. That step we are not doing. We are directly using a keyword search, that is BM25 algorithm, again, which is very popular algorithm nowadays, and most of the organizations are using it over embedding because it saves your cost as well. You don't need to spend a token in embedding this query and embedding the existing chunks as well. So that's the reason the organizations are using this BM25. Now let's go back to our code. Now the index creation is done. Now we can go ahead and upload the chunk. So for uploading the chunk, the code is written in this file. So if you see the documents that we are uploading after from the chunks is this. First, the ID, the company, year, source file, content vector. These are the details it will be dumping into the vector store. And for the retrieval, this is the code which we will talk about. So as I mentioned, we are using a keyword based search. So if you see the filter expressions, once the document is extracted, it will filter that document with the help of company and year, so that it will make sure only the relevant entries are extracted. So here we are using top K as 20. It will extract 20 documents, out of which, let's say if you are retrieving the document or content only for Apple, it will filter out that for the Apple. So that's how the extraction will work. Now let's go to the ingestion and let's run this particular file. So again, come back one step, come to the base folder and run this file. Python -m ingestion ingest documents. So this will now check for that ingestion, and if you see it has started the ingestion of this particular file. So first it will do the semantic chunking, then it will that semantic chunking, it will upload it into the vector store. So let's wait for that. Okay, you can see it has generated 23 chunks. Now it will load those chunks onto the vector store, and then it will pick up the second file. Okay, uploaded 23 out of 23 chunks. Okay, now I'm getting this error because the model that I'm using, right, it has hit the limit. It was able to uh, embed all the chunks first, but now for the second semantic chunking, the model is failing. So I'll have to increase the rate. So the rate that we set right here, again, if you go back to the Foundry and if you go to the models and endpoints, if you click on edit, you can increase the rate here, but if you increase the rate, it will incur cost as well. So this rate, currently we have set it to 150 because we have large files. That's where it is a challenge, and that these are the real challenges that we face in the industry. Because what happens when you do a toy project, right, or a POC, you pick very sample data set, very small data set, and the application works smooth on that particular documents. But when it comes to the actual documents, these are the challenges that you face, and then in those cases you will have to improve this, or you will have to add a wait timer so that it will wait for a minute once this particular error has obtained in order to avoid the interruptions. So that's how we handle it. For now, let's ignore it. One file is uploaded successfully, so let's go ahead and check that. So now I'm going into the documents. It will take some time to reflect those documents, so let's go ahead and refresh it. So it will definitely take some time, but yeah, I'll show you it. If you start searching here, let's say Apple, it was related to the Apple, so it will extract the details. So if you see, it is retrieving the detail. This is the ID, company is Apple, year is 2025, source file is this, and content is this. So yeah, that's how it has created a dynamic ID, and that's how it has stored the data. Now, whenever user is searching any question, it will be matched with this particular content. It will retrieve the content and then it will filter it for company Apple and 2024 year. So that's how the filterable and searchable components will work. The one that we discussed here, right? The company and years are filterable, whereas the content and string, that is searchable. So that's how it's going to happen. Now, this part is done. We have done the ingestion. Let me show you if the documents are available now. Okay, so if you see 23 documents, 23 chunks that we saw here. So if you see 23 chunks it has created, it has uploaded all the 23 chunks. It took this much memory. Max storage we have 15 GB. So if you are using one file, then you can go ahead with the free service as well. Okay, this part is done. Now our vector store ingestion is done. So if you go back to the whiteboard, now here this part is also done, vector store. Now we need to build the logic to retrieve the content out of this. So now we will actually hit to the vector store and retrieve the content related to the revenue, the total sales, assets and everything, risk and growth. All those KPIs we will retrieve it from the vector store. Then we will pass it to the GPT-5 model. So let's go ahead and dissect that particular part as well. Okay, so as the vector store ingestion is done, now we can work on retrieving the content. So let's go back and see our workflow. So this particular part is done, vector store ingestion. Now let's work on this KPI extraction. So we need to extract these KPIs. So let's start working on it. So for that, again, based on the modular code that we have written, you can go to this particular RAG operation, because now it's the retrieval, then we will augment it and we'll generate the output. So it's the RAG operation that actually will happen here. So I have created a constructor in order to mark this particular folder as a module. Let's work on this KPI extractor.rag. Sorry, KPI extractor rag.py. So in this code, so first of all, we are importing the LLM because now it's a RAG operation. First, we will retrieve the content, feed it to the LLM, right? So this part we are seeing now. First, we will retrieve the content and then we will pass it to the GPT-5 to generate the structure output. So this part, now we are going to see it together. So let's work on it. So first of all, we will need a LLM. So let's go to this particular code. So which is written under LLM. So if you go to this LLM and if you expand it, you can see Azure OpenAI.py. Now here we need these three details, the Azure OpenAPI key, which we already have it, then Azure OpenAI API version, and the OpenAI API endpoint. So again, let's open our .env and we need to grab these details. So we need these details now. Key we already have. We need OpenAPI endpoint. Then this one for chat model, we have already created it for the endpoint. Now we need it for the chat model and the OpenAPI version for the chat model. So let's go to the Foundry and we will create these services first. Okay, so let's come here again, go to the models and endpoint sections, click on deploy model, deploy base model, and here let's select GPT-5. We'll be using a GPT-5 chat interface model. So let's select that. If you scroll down GPT-5 chat completions, if you see this is the model that we'll be using, let's click on confirm. You can use either GPT-5, you can go ahead with GPT-4 as well, 4.0 as well. So let's click on customize and it is selected 150K token. I think this is more than enough. So let's go ahead and deploy it. So it's creating the deployment, should not take much time. Okay, the deployment is done. We got the endpoint, so let's copy this endpoint and we will pass this endpoint here, chat endpoint. So let's replace this with the endpoint. Okay, the endpoint we have replaced it. Key is already same. So if you see, it starts with 7F and ends with FD. I think it's the same key. Start with 7F, ends with FD. So okay, key is same. Version. So you can get the version from here. So this is the version 2024 1201 preview. Okay, the same version is added. So that should work now. Okay, so this part is also done. Now come to the this one, and again it is importing the Azure AI search vector store from vector store.azure AI. So if you go to this, so if you see this is a file under vector store where we have written the code for retrieval. So if you see we have a retrieval class which is retrieving the top 20 records from the vector store, and it has a code to connect to the client as well. So client in this is it connects to the Azure AI search as well, right? So if you see here it is connecting, creating the client. So let's go and let's deep dive into this code, KPI extractor. So if you see this is the retriever, we are retrieving it. Then this is the content that we are retrieving. We are passing this particular query while retrieving the content. Now we need details related to the annual financial statement, income statement, balance sheet, cash flow statement, risk, growth drivers, financial performance for the company that we will pass and for the year. So this query will be hit to the vector store and out of this it will retrieve the document. First of all, let's hit this query on the Azure vector store. So let's go to the AI search and here we'll try to hit this query and we'll see what information that we are getting. So instead of here, let me pass year 2024 and for company, let's pass it as Apple and let's search it. Okay, so if you see it is retrieving the content related to the financial statements and other information related to the sales and everything, right? So this is what it will return the top 20 results, and these results then we will feed it to the LLM. So if you see in the documents, we will get those documents and then we will pass the document into the build extraction prompt. Here we are building the prompt. This prompt we will be passing it to the LLM GPT-5 model. So if you see you are an expert financial analyst for this particular company, this is the context that we have retrieved. Extract the following information out of that revenue and these top 8 KPIs. So we are retrieving that top 8 KPIs out of which, and this is the instructions that we have given. Return only a valid JSON object. And then we have added extract financial matrices, the final code where it is coming, accumulating all the details. Like first it is retrieving the content, then building the prompt, and then the extracting the matrices. And in the main function, if you see, first the retrieval will retrieve it, then it will pass that retrieval to these particular results and it will generate the final result. So first of all, let's see if we can print the context that is retrieved. So let's go ahead and click on print here. We are printing the context, and let's for now we can comment this step passing it to the result, and let's comment this one as well. Okay, we'll have to comment everything and let's run this particular file. So it should go ahead and retrieve the content. So to run this file, again we are at base folder, so we'll be using an Python module. So Python -m and it's under rag dot KPI extractor. Let's go ahead and execute. Uh, no module name rag KPI extractor. Let's see. Okay, KPI extractor rag underscore rag. Okay, so it should go and retrieve it. Okay, it is not printing it. Ideally, we should print not context. We should print the retrieval. So if you go to the retrieval documents, you can print these documents here. And now let's hit the query. Oh, sorry, we'll have to enable this part. Now let's see. Now it should go to the vector store and retrieve. So if you see, this is the document that it is retrieving, the exact document. So if you see top 20 results, these are the top 20 results available in the document. We are passing this information to our large language model. So if you see, it starts with 2024 form 10K20. That is what exactly is retrieved here. So if you see form 24 10K20. So it is doing the retrieval task. Now this retrieval, what we have done is, as part of this, we have retrieved the information. We are passing this to the LLM to extract only this part in the JSON structured output format. So now let's come back. Let me comment out that cell that we added, the print statement. And now let's enable this and we will print the extracted results as well. Okay. Now let's go ahead and execute this. Clear it. And again, let's execute python -m rag kpi extractor dot kpi extractor -rag. Now it will extract the actual documents out of it. Okay, let's see what's the problem. OpenAI does not exist if it is created within last okay resource. Okay, might be something is wrong in the environment. Let's go ahead and check it. OpenAI version is correct. Chat OpenAI endpoint is correct. Model name, I think model name is misleading. Let's check the model name in the deployed one. Okay, so the model name is GPT-5. So we'll have to replace this with GPT-5. That was the issue. Okay, quick fix. Let's go ahead and execute this again. It should work now. Now it is hitting the request to the vector store, retrieving the content. Retrieval content it is passing to the LLM, GPT-5, and LLM is getting the structured output out of that. All the 8 KPIs that are required to showcase on the user interface, it is retrieving that content. So it will take some time. So let's wait for that. Okay, you can see it has retrieved the content. So if you see, this is what it is retrieving. This is the revenue and all this, and these are the top risk factors and top growth drivers. So this information is retrieved by the GPT-5 model out of that document that we passed. So isn't it interesting? So it's working. And if you see expected KPIs, these are the KPIs we have printed. So it's just printing it again. Meaning this retrieval part is working, and this is what we wanted to showcase on the UI. Now, why structured output? Because this JSON object, we will pass it to the user interface. This backend API, right, it will return this JSON object, and the UI will consume this backend API response. So that response should be in the structured format. Then only the UI will work. So that's the reason we are generating it in the structured format. Okay, so this is cool. It is generating this data. Now, the next step is we need to ingest these matrices into the SQL database, because if you remember, we discussed in the diagram here that once the AI search retrieves the information, it is a one-time extraction which will be ingested into the SQL database. So this part is now going to happen, retrieval ingestion. So let's work on this. So for that, we need to create this Azure database for PostgreSQL flexible server. So again, let's go to this Azure portal and let's search for Azure Postgre. Okay, once you search, you will see this Azure database for PostgreSQL flexible server. So let's click on it. Let's click on create. Again, this is again a costly service, so please be mindful while using this service. So I'm selecting the existing resource group. Then dev production, we can select dev because that way will incur a less cost. It will incur a less cost, and this is the machine that it will give us: 2-core CPU, 4 GB RAM, 32 GB storage, which is more than enough for us. Again, it is overkill for us, but that's the minimum available. Availability, no preferences. And here you can select the PostgreSQL authentication only. And for this, you can add a login. So you can use your login. Let me use my login so that I no need to change this particular env file. So administration login, let's use itech. Password, I'm using this password, rag @12345. So let's use that rag password. And let's add the confirm password. So this is done. Let's click on next and review and networking. So if you see the estimated total cost, it's close to $58 a month, which is pretty big number, right? And that's where once you are done with utilizing the service, please go ahead and delete the service. So let's click on next. Public access is enable. Next, review and create, and click on create. Okay, something is failing. Okay, server name should not be empty. Okay, let's pass the server name as investor intelligence. Okay, let's review and create. This you can skip it. Create server without firewall rules. Again, firewall and all, right, it is required once you actually work on the industry. You need to take care of the security perspective as well. So you need to add the IP address. For those IP addresses, only this particular service will be utilized. So basically, you'll be doing the IP address whitelisting and all that stuff. But yeah, for us, let's ignore that part because we're not going into the security details. But yeah, if you guys are interested and if you guys want me to cover that as well, maybe you can drop that in the comment sections. And in this series itself, at the last, I will cover those details as well. So I'm going to extend this series. Basically, we are going to cover the CI/CD and everything, right? The deployment as well. So this is going to be the pretty interesting one. So this will take some time to basically deploy this service. Once this service is available, we just need to grab several details and we need to drop those details into the env file, and then we'll be able to connect to this particular server. Meanwhile, we can go ahead and install the pgadmin. Pgadmin is a tool which is helpful in order to connect to this particular server. So it's an application just like our MySQL. For connecting to the Postgres server, we have a pgadmin as a tool. So you can go to the pgadmin and just install the pgadmin. So you can go to the download sections, and based on your application, based on your system, you can go ahead and download. So for Windows, I have a Windows, so I have downloaded this latest released on the May 11th. You can download it, install it. Once you install it, it will look something like this. Or let me close all that stuff. Yeah, so once you install, it will look something like this. And here you can connect to the Azure SQL that you are creating, the PostgreSQL. So let's wait for that creation. Let's refresh. Yeah, it will take some time because it's a database creation. Okay, so if you see the deployment is succeed, so let's go to the service. So this is our Azure database for PostgreSQL flexible server. So first of all, we need a endpoint detail. So you can see this endpoint, you can copy this endpoint, and we need to pass this endpoint into our code. So if you see this Postgre host, let's replace this host with the one that we created. Okay. Now this part is done. Port is same 5432. Database name is this one only, financial intelligence. Postgre user is itech, that's what we have given, and password we have given rag@12345. So we are good. Now we can go, and if you see under the connects, you will find the details with which you can connect to this particular server. So if you click on this pgadmin, right, the one that we have installed, you will get the details and all things that is required in order to connect to that. Plus, if you select VS Code, you can directly connect to this particular service through VS Code extension as well. So there are a couple of ways available with which you can connect. Now what we are going to do under the database sections, currently, if you see, these are the default database that it has created, but we are going to create our own database. That is financial document. So that's what we have defined here. If you see financial intelligence, sorry. So what we can do, we can now connect this to our pgadmin. So you can come to the pgadmin and you can click on create server group, and let me give name it as intelligence is the group. Let's save it, and under this group Now we can go ahead and register a server. So here we just need to give the name. Name is our investor Intel. That's the name. And under which, if you go to the connections, we need to pass the host name or address. So those we can again copy from here. The same thing. First, we need to pass the host name. Port is similar, 5432, Postgres maintenance database. Database name, we need to change it to the financial intelligence. We'll be creating it. Then username is iTech. iTech is our YouTube channel. So if you have not subscribed to the channel, please go ahead and do that. That's what we have mentioned, and the password. So let's grab the password as well, and we will add the password. So this is the password, and done, save it. Now financial intelligence is not available, so let's see if it is throwing any error. If it throws the error, first of all, we'll have to go ahead and create this. Okay, so unable to connect, so that's fine. First, come to the code and you will find the folder called database. So let me hide all the rest of the details. Under database, if you see, we have create table .py. So you can go to this. First of all, we will have to create the table. So first it will create the database and then it will create the tables underneath. So first of all, let me hide this and we will create the database. First it will check whether the database is available or not. Where we have defined that. So if you see, we are importing this particular create database and get engine from the PostgreSQL, so from this file. So if you go to the PostgreSQL, here we have defined these details: host, port, user, password, and database name, right? Postgre database. So this is our engine which helps our code in order to connect to the PostgreSQL with the help of these connection details. So it is here we are building the connection and it is connecting it, and then this is the code written in order to create the database first, right? So if the database is not available, then it will create. So these queries, it is just checking whether the databases exist or not. So again, if you go to the create table.py, here we are only running this particular first file. So again, in order to run that, we'll be using modular approach. So python -yum, and it's available under database dot create table, and let's execute. Could not translate host name. Okay, why it is picking DB? I think there's some issue. That should not happen. Let's go to the PostgreSQL. We may have hard coded something. Let's check that. Oh, I think this file is not saved. Yeah, now it should work. Let's execute this. Now it should work. Sorry, the .env was not saved. Now it will pick up the latest name and it will basically connect and create the database. Once the database is created, I'll show you that on the pgadmin. Now with the help of engine, it is connecting to the PostgreSQL, the flexible SQL server that we have created. And once the database is created, we will go ahead and create the table as well. Okay, we faced one issue. Connection timed out. Failed to connect. Is the server still running? Okay, let's check. Looks like there is some issue. We can come to the overview. Let's enable. The firewall was blocking this, so we will have to update the connection security settings. So let's update it. And let me see if there is anything that I have missed. Okay, now the service is available. Earlier this was blocked, so we have now enabled it. So let's go ahead and run this file again. Now it should work. Okay, so if you see, database does not exist. Creating database financial intelligence created successfully. Okay, so you can go to this portal and you can check here under databases section. You should see the financial intelligence. If you see, this is the database that is created. Now, how to view this? Again, you can go to pgadmin. And now, whatever details that we have mentioned here, financial intelligence and all, let's give it a try again. So let's click on save. Now this should be connecting to this server that we have created. Okay, you can see the server connection is successful. And if you expand this inventory intel under databases, you will find the database that we have created. If you see, financial intelligence is the database that is created. If you expand this, and there is this schemas, under schemas you will find the table information that is available. So currently there is no table that we have created, so let's go ahead and create the table first. So again, come to the code, and this is the table that we'll be creating: ID, company, year, revenue, all the 8 matrices along with the ID. And one more column is there, created at. So 10 columns we are creating. So let me enable this now, and let's run this file again. So this should go ahead and create the table. Okay, database already exists, so it is skipping that. So it should go ahead and create the table now. Okay, financial metrics table created. So as per this query, it has created the table financial metrics. Now let's go ahead and check that. Here again, let me just refresh it. Okay, so under this particular public, if you expand the table section now, you should see the table. Okay, you can see financial table, sorry, financial metrics available. Now let's query this particular part. Let's open the query tool. This will take us to the query tool, and here you can run command select star from financial metrics, and let's run this. Okay, so if you see, this is the table that it has created with all these 10 columns, and currently there is no information available. Now, as part of our this activity, we have created this PostgreSQL server as well. Now we have this structured output that is obtained after the GPT-5. We just need to pass that output to this particular code so that we can ingest to this part, so that we can ingest it into the PostgreSQL. And once that ingestion is done, then only the leftover part is creating this user interface that we will talk about. So again, come to the code, and then you will find this particular part, metrics.py. It is this file is the serving file. I'll come to this file later on. First is the save matrices. So with this, we are saving these matrices to the database. So in the ingestion file, we have restricted some of the details. So to test this particular save matrices, what I have done is, so if you see, we are importing the PostgreSQL get engine, the engine that we discussed to connect to the PostgreSQL. Then insert into financial metrics. This is the query that we are using to ingest. Now again, we have hard coded the table names and all those details. You can keep it dynamic. So when you work on the actual industry projects, you parameterize all these values into the environment file, and accordingly you call these values, so that if you want to change the tables and all those details, you can do that later on. Now, this is what the parameters that we are passing, and we'll be ingesting these parameters. These parameters we are getting it from the Azure OpenAI. But for now, I have created a sample matrix that we can go ahead and test the ingestion. So company is Apple 2024, and this is the matrix. So let's go ahead and test it. Again, to run this, we can use, okay, it is getting, my face is hiding this particular, so sorry for that. Python -m, and then again it's under database dot save metrics. Let's hit enter. Oh, no module name save metrics. What's the problem? Oh, spelling mistake, sorry. Now this should go ahead and ingest the data into the vector store, into the SQL server. Okay, successfully saved the matrix. So let's go ahead and double check. So again, now I am executing this code. It should see one row. Okay, you can see first row, Apple 2024. This is my revenue, net income, operating income, cash flow, and all this information, risk factor. Then we have the growth drivers, and at the end, the timestamp when it was created. So this is the today's timestamp. So okay, it's working cool. Now this information will be served to the user interface as we discussed here. Now this part is also done. It will be served to the user interface, but currently we have passed a fixed format here, a custom data set, but now we just need to connect this part to this one, so that whenever the KPIs are extracted, it will be directly ingested into the PostgreSQL as a one-time activity, as we discussed here. It will be ingested into the PostgreSQL. So that part now we need to work on, and also we need to work on configuring these particular complete RAG. Once the user ingests the report, it should go ahead and do this activity simultaneously and ingest everything together. So we need to map all these. So what we will be doing is we will be creating a backend APIs where we are going to wrap all these functions together We are going to call it and we are going to build these routes. And those routes, we will call it into the app.py file to execute it. So now the important part of the code is connecting it. So in order to connect this, so if you go to the rag folder and under KPI extractor.py, at the bottom we have this particular code which does that activity. So in this code, we were getting the KPI matrices. Now, if you enable this, it will go ahead and dump this data into the into our vector store. So if you see save matrices, we are calling it from the database. So the same file we are calling, same module, the save ingestion, save matrix, sorry, this one. Now, and as I mentioned, as we ran this particular file, that's where this underscore main function worked. But when we are calling this into the KPI extractor.rag, it will skip that part because now we are not running this file as a main. It is imported as a module. So it will execute whatever information that we will pass from this particular Python file. That was the reason. So let's go ahead and now execute this file again. So Python, it's under, sorry, Python -yum, it's under rag.kpi extractor underscore rag. Now this should again retrieve the content. Again, it's a one-time activity as I mentioned. So in the UI, we are going to configure it in the same phase. Whenever user uploads the file, it will call this particular function one time and it will save those KPIs. So now it is again hitting to the vector store. From vector store, it will retrieve the content, pass it to the GPT-5 model, and from the GPT-5 model, it will so from the GPT-5 model, it will generate the structure output and ingest that into the Postgres SQL now. So let's wait for this. Again, it will take some time. So okay, so if you see, it has extracted the matrices. These are the matrices. Now these matrices, it will pass it to the PostgreSQL. So if you see, successfully saved the matrix for Apple 2024. Let's see whether the new entry has been made or not. So let's go ahead and again execute this. You should see the two records. Okay, you can see second, same information it has extracted because eventually we have retrieved the same content. But if you see the timestamp, there is a difference in the timestamp. It was around 54th minute. This is around 57th minute. So that's how it is doing the whole operation. And the matrix.py file that I mentioned here, right? Again, we'll come to that file, matrix.py. This is basically pulling the latest. So if you see this particular query that we have written, it is checking if there are more than one commonalities across the company. So if there are two times the companies occurring for the same year, then it is pulling the latest one that is available. So on the UI, you will see only the latest record. So that's how we have enabled it. Okay, so we have built 90% of our application. From this point till this point, everything is set up now. Now the next thing is we need to accumulate these into a routes and we need to build an user interface. Now, for the user interface, again, as we have used HTML and CSS, so you will find two folders created under this. One is static, where we have the styling information added for the user interface. And then we have templates where we have defined the template, right? Where should these particular components should be there on sidebar, there should be chatbot and all that stuff. So that is mentioned here. But the one thing that we need to try it out is first the routes. So if you go to the routes folder, you will find all the routes that we have created. Now the first route is for ingestion.py. So if you see /upload is the route. Whenever we are calling this route, again, we have imported all the functionalities here. So if you see from the vector store.azure, we are importing this. From Langchain OpenAI, from ingestion, we are importing ingest document. And that we are calling it in this route in order to perform that activity. So that's how we have created the route for checking the health. We have created the route for dashboard, showing the dashboard matrices. So if you see get engine matrices, the same query that we have written. Chatbot.py, this I missed to cover. So this part of the application, this chat interface. So whenever user asks any follow-up questions or any query, those queries will be hit to the vector store and vector store will generate the GPT-5 output. It will be responded back. So that part is again covered. So let me go over that as well. Under routes, you will find this chat.py file. So if you see in this chat route, this is the prompt. It is hitting to the vector store, getting the response, and that response then it is sending back to the user. So if you see first here, it is retrieving the content. That retrieved content, it is generating the final response by passing it to the LLM and generating the final result answer. So that's the thing. Now this part is also done. So what I have done is I have created one main.py where I have accumulated these backend APIs. at least few backend APIs. So let's go ahead and check this. Again, main.py, we are using fast API in order to build this framework. Fast API is a Python framework to build the backend applications. So if you see first, we are giving the title. This is the initial title that I gave. Let me change it to investor intelligence. This is just for the testing purpose. First, we are checking health of the application, then ingestion and the dashboard. Those two things. Chatbot is missing here, but yeah, you can go ahead and add that. So to run this, you can again use Python main.py, simple thing. This should spun up the user interface for us. Okay, you can see. Let's go to this. Oh, sorry, it is opening in here. Let me go to the, and here you can go to localhost 8000 port. Let's see, it should open the 8000 port. Okay, there is some issue. Let's check whether it is taking us to the docs page. Okay, let me see what's the issue. Okay, so there was a small mistake. So actually it is running on port 8080, not on 8000. For app.py, I have kept the port 8000. So that was my mistake. So let's go ahead and run the application again. Okay, so you can see it has loaded this particular application. So let's go to the localhost and test it. So localhost, and we'll have to go to the port 8080. And if you go to the docs, so if you go to the base, you will see details not found, because we need an Swagger page in order to test this. So the Swagger page of FastAPI is available at docs. So /docs you do, and you will find these APIs. So currently I've just added one API. So if you try it out and execute this, you can see it is healthy. And second route that we have added is the API matrices. So if you try it out and execute it, it will retrieve the information related to the Apple. So few things I have, just for the testing purpose, I have hard coded this Apple and all those details, but it is retrieving these content from the vector store, from the data that is we have ingested into the PostgreSQL. So if you see ID2 and then Apple and company, so that exact data is available under this PG admin. So ID2 and this Apple and all that information. So it is extracting that. And the same query it is using in order to avoid the duplicates and all. So that's how we have written other backend functionalities, and those now is getting utilized into the user interface. Now in this project, we don't have separate microservice for backend and user interface. That's where all the APIs are not available on this page, but I've integrated those directly into the user interface in the app.py, and I'll show you that. But when you work for the industry, you ideally create separate microservice. So in this page, you will be able to see all the APIs that you have written. Plus, you should see the authentication as well. So currently, the authentication is missing here. We don't see any authentication available. So, or else you will see the authentication part. First, you will have to authenticate the application. Then only you can access these APIs. So that's how the secure mechanism is built in order to access the APIs as well. So this is for the backend API with the help of fast API that we have built. Now let's go ahead and see the user interface code. Now let's terminate this, and that code starts from the app.py. So this is our final file where all the integration code is written. So if you see, first we have the APIs in order to ingest, then we have API in order to chat, then we have the templates and static folder that we have written, and this is the complete code that we have written and which runs on 8000 port. So first of all, let's go ahead and execute this. But as I mentioned, right, this user interface related code is available on these two files. And again, I'm not going ahead with these files because again, it's not that important, because you can build this particular user interface, and ideally we are not responsible to build the user interface as a data scientist. So that's where you can skip it. And now let me go ahead and run the file python app.py, which should load our actual application. Okay, it is running on port 8000. So let's go to the user interface and let's go to the localhost 8000. So you should see the user interface now. If there are any issues, we'll fix it, but let's wait. Okay, cool. This is the final application now that we have built, which is where if you see, we can see the data for Apple now. We don't have the information related to the other two that we have ingested, because that information is not there in the the Microsoft and Tesla information is not ingested yet into the vectors into the vector store as well as into the PostgreSQL. So again, I think you might. So, and on the right side, this is our what we can say. This is our chatbot that we have built. So here you can ask the questions, you can select the companies and ask the questions. And below, if you see, we have these matrices, the growth matrix and the top risk. Again, you can select the, from the filter, you can select the company as well. So currently only one company is there and only one company is ingested. So that's the reason. So, and here you can see iTech. So if you like this particular series till this point, please go ahead and give it a like and subscribe to the YouTube channel as well. Because I'm putting a lot of efforts in coming up with these good projects, a real-time industry projects in front of you, and that too on YouTube. I'm sharing all the details, all the resources, code, everything I'm sharing. So it's totally free, accessible to everyone. So at least I'm expecting this like and subscribe and comment from your side. Okay, the next part is now let's test it whether the application is working. So let's click on ingestion and let me go to the folder and we'll ingest the data. So under data, we have raw PDFs. So let's ingest the Tesla PDF now. So if you see now the uploading is going on and let me show you the code meanwhile. So it will print. So if you see ingesting Tesla 2024, company Tesla year 2024. So this particular ingestion has started and you can see on the UI, it is uploading the data. So it will take some time now. Let's wait. So here you will see all the processes that are happening. And once this particular data is ingested, then I'll show you how it is ingested into the PostgreSQL as well. So everything is happening automatically now. I'm just hoping it should not throw the error because of the large language model that we have used for embedding, or else we'll have to increase the limit of that model. So let's see if it fails, well and good, we will fix it. That's fine. Failures are always good because that way we get to learn new things. So let's wait for it. So if it fails, we'll go ahead and increase the limit. Okay, you can see generated 21 chunks for the Tesla file. So for the Apple file, we created 23 chunks. Now it has created 21 chunks for this. Now it will load this data to the vector store first. Then it will retrieve the content out of that, the KPIs required for the user interface. It will ingest that KPIs into the PostgreSQL, which is a one-time activity. So it will perform all those steps. That's where it is taking time. So on the user interface, if you see now, it is still saying uploading the report, but yeah, in the backend, if you see, it is okay, uploaded the chunks. So now it should say it will start the extraction part. It's taking time because we have a huge files with us. And again, we have selected low parameters for the models like the token per minute and everything. So that's where it is slow. Okay, so you can see it has extracted these details out of this particular which file we imported, Tesla file, sorry. Out of this Tesla file, it has imported these details. Now, if you see successfully save the matrices for Tesla 2024, and on the user interface, if you see success message, so that is done. Now, the moment it has completed, you can see the Tesla information is available. The revenue is $97K. Then net income is again 7K. All that information is already populated. And you can see below now the Tesla is also available, and you can see the top growth and risk factors for Tesla. And here also you can see in the company is available. That is, let's select Tesla, and here you can ask the follow-up questions. Let's say what's the total revenue of Tesla in 2024. So whenever you are hitting this query, now it is hitting to the vector store, retrieving the content, and then it will deliver the response to us. So if you see, this is the total revenue, but for the year 2024, if you see, the revenue is 97K. So that's what we have mentioned here. This is the data for 2024K. So this particular chatbot is also working. So now we have covered all the parameters that we wanted to build as part of this particular application. Okay, so what else is pending now? So now you can go ahead and try it out. You can try uploading one more document. You can go to here and upload the new document for Microsoft, and you will see the Microsoft information will start populating here. So I missed to showcase the data that is available in the Postgre. So if you see on the Postgre, it has ingested the data for Tesla, and this is what it is used for serving the user interface. And if you go to the vector store, you will see the information related to AI search as well. So sorry, related to the Tesla as well. So if you again go to the AIS and go to the indexes, now you can see the count has increased to 43. And here if you search now Tesla, you should be able to see the Tesla information. So you can see Tesla is already available. And if you search Microsoft, it should not give any results because we have not ingested anything related to the Microsoft. So Okay, you can see 0 results. So that's how this particular whole application is working. I hope this application was helpful for you. I hope you were able to connect the dots. I hope you were able to build the end-to-end flow out of this particular application. I hope you like the user interface. And if you have any questions, please feel free to drop them into the comment sections. Please go ahead and try it out this project. I would highly recommend create a free Azure subscription, create those services, all services that we have created as part of this video. Try it out, execute this code, just execute the code, clone the repository, add the environment configs and execute the code. And once you execute it, you can add these particular codes into the resume as well. But this is not the end of the series, guys. Now we are going to focus on deploying this particular application, because whatever request I got, right, to cover the end-to-end RAG application. So in my mind, end-to-end is meaning we should cover the deployment as well. Currently, this particular application is serving on local. We need to host this particular application on some cloud server so that anyone can access this particular application. Obviously, I'll not be able to keep this application open for you guys to test, but in the deployment part, we will deploy it, we will test it, and maybe I'll have to take that application down in order to save the cost. Now this part is done, so what I will go ahead and do, I can go to the my this particular service, Azure AI service, and I can I can go to my Azure portal, and you should delete all these services. And the best way to delete these services is go to the resource group and delete the resource group itself. So we have created all the services beneath this resource group. So you should go ahead and delete the resource group. I'm going to delete it, and at the time of CI/CD, I will again create these services in order to save the cost, because these services, right, this part and the AIS services, these charges us on monthly basis, right? So even though if you don't use these services, it will keep charging you. So better to delete this service for now, and that way it will not incur much cost. So just to show you the cost that I have obtained till now, so let me go to the cost analysis section and I'll show you the cost. Okay, so if you see, since yesterday I'm trying it out. So yesterday I gave the demo, I recorded the demonstration application, and then today I recorded this particular, we have done this coding part. So if you see, the cost is 335 rupees, and you can see the spike, sudden spike in the cost. So this is cost approximately per day we are getting, and you can see the distribution. Azure Cognitive Services are using 183, meaning the AI search. Then the OpenAI services that we are using, it is consuming 183 rupees. 144 is for this PostgreSQL server that we have used. You might be surprised that, okay, we have just ingested 3 rows, but it has calculated this much cost. And the Foundry models that we have deployed, it is the cost related to that. Okay, one mistake I made. So this is the cost related to the work that I have done yesterday, but same type of work I have done. Like I gave the demo, right? In the part 1 video, I gave the demo. So this is the cost related to that demo. So today's cost will also be reflected maybe by tomorrow, and it will be again around this same figure, close to 330 or 350 rupees per day. So if you are doing this activity every day, right, it will incur this much cost. So I would recommend go ahead and delete the resources. That's the reason I expect at least a like and subscribe from you guys. So yeah, that's it. So see you soon in the next video, where we will start working on the CI/CD. So if you remember, at the start of this particular series, we decided that we will not only develop the application, but we will also focus on deployment. So till this point, we have already developed the application, and the code is available on my GitHub. You can go ahead and check out that. The links are there in the description below. Now, as the development is done, now it's time to move towards the deployment. And in every organization, deployment is a very important step, because that gives the feasibility for your end users to consume the application. So whatever deployment development that we have done till now, it is only in your local. Now how you are going to make your application accessible to outside users, and that is where the deployment comes handy. So, and as we discussed, we will be using an Azure resources in order to deploy the applications. So first of all, we will be containerizing the application with the help of Docker. We'll talk about that. And post which we will be using an AKS, that is Azure Kubernetes service, which is a managed service from the Azure, in order to deploy our application. So this manages the application deployment. So we are going to dissect each and every component. So let's hold on for that. So first of all, let's get started with the Docker. So what exactly is the Docker? So first of all, what I would recommend, go ahead and install the Docker desktop if you have not. So you can go to the Docker desktop, and you can go to the install, and you can install the Docker desktop based on your system. It's not a big deal, just install the Docker. Now what Docker does is, so first of all, these are the components of Docker. So first one is the client. So client gives the feasibility to connect the local users to a Docker host. Just like how we connect to the GitHub using Git commands, right? Like git pull, git push. We connect to the Git. So Git is again a host to which we connect using Git commands. So similarly, client provides us the connectivity to connect to the host, and these, if you see, these are the Docker commands like docker run, build, and pull. So with the help of these commands, we connect to the Docker host. Again, this is not the video related to the Docker, but I'll try to give as much as detail possible. Now in the Docker host, we have Docker daemon. So Docker daemon receives these particular commands and accordingly it behaves. Behaves meaning, let's say if the user is saying Docker run, this Docker daemon accepts that command and run the container. So those are the task of Docker daemon. And then we have images. Now images is the replica of your application. So you can create more than one images for same applications, which is going to be the replica of your application. Replica in the sense all the details that you have mentioned, right? Like for example, your whatever steps are required in order to run your application, like you will have to install the dependencies, you will have to copy the code, you will have to run the file, right? So all those details are managed in this particular image. So it is a static object of your application, and containers is a runnable object of your application. So the basic idea behind using Docker is why Docker is famous and why most of the people use Docker in order to deploy the application. Because whenever you build any application, we always face the issue that, okay, your application works in your local, but whenever you deploy the application, it does not work because same level of dependencies might not work on the deployed environment. There may be some configuration issues that you have in your local that you have fixed it. Those issues you will again get it into the production environment or wherever you are deploying the application. And in order to avoid those issues, right, that's where we use Docker. And what Docker does, it containerize your application, meaning it ships, it combines your complete code into one container and it ships that container to the new environments. Now whenever we will be using that particular container, if that container is running on your local systems, then that container will be running on any of the systems wherever you are going to deploy it. So that's the task of Docker. So basically it containerizes the application, and once the application is containerized and you make sure that it's running your local, now you are confident that, okay, the code will work onto the deployment environment as well. That's the task of Docker. And as we already explained the images and containers, now once these particular containers and images are ready, then we push these particular images to the registry. Now registry is a place which register your images, meaning which keep your images into the registry. Now whenever we will first write our Docker file and we will test the application in local, at that time the registry is going to be our local registry. But for our application, we are going to use a registry again, which is a service provided by the Azure, which is Azure Container Registry. We call it as ACR. We'll be using that service. Okay, so that's the basic related to the Docker. Now let's get started on writing our Docker file. So I'm going back to our code. Okay, so this is the code that we have written in the last video. Now let's go ahead and create the Docker file. So first of all, in order to create the Docker file, you can create and you can give the name as Docker file. Just give the name as Docker file and hit enter. So this will make sure the file is recognized as Docker. So if you see, it is a Docker file. Now to write the Docker file, first of all, we will have to set, like whenever you want to build any application, right, what you need is the environment. Like you will need Python environment, base Python environment, on top of which you will run this particular application. Now the environment where we are going to ship this, right, we don't know whether the Python is installed in that particular environment or not. So we need to install that Python, and for that we need one image. So this image is basically clone a sample. You can use a base image, and on top of that you can make progressive steps. You can add progressive steps in order to build your own image. So that's the standard industry practices. Now in order to set up the Python, we are not going to install any dependencies. We are going to use a predefined image, which is a open source image. We will be using that image. Now the command is very simple. For that you will get that command anywhere. So if you see, we are using lightweight Python image from Python 3.12 slim. Slim is the lightweight image. Now this will make sure that it will go ahead and clone, it will go ahead and download this particular image, and on top of this image we will write our further Docker file. So first step is to define the Python, so that we have done. Now the next step is to define the working directory. Now defining working directory, why it is required? So it is very simple. You can use the word work dir and /app, meaning whatever code that we have in this particular folder, it will be dumped into the deployment environment. It will create app as a folder, and into that app folder it will dump all these codes, whatever metadata that we will be pushing. So that's the reason we need to define the working directory of our deployment environment. Then next step is in our application we follow installing the dependencies. Now in order to install the dependencies, we have used UV as a Python package manager. So first of all, in this Python environment 3.12, let's go ahead and run pip install UV. Now run command is basically in order to run if you want to run anything. So this will make sure that it will install the UV as a Python package package manager into Python 3.12. Then next step is, once the installations is done, then we need to copy the requirements. So with the help of copy command, you can do the requirements.txt, and it will make sure that it will copy this particular requirement.txt which is available at this location. So if you see in the file location, in the root directory we have requirements.txt, which will be copied into /, meaning in this particular working directory it will add this particular requirements.txt. Then next command is we need to run in order to install the dependencies. So this is a command, run uv pip install --system -r requirements.txt. This will install these dependencies into the system. And why we are using UV? Because again, in order to speed up the installation, we are using UV. Now next thing is we need to copy the rest of the application code. So in this particular working directory that we have created, we are going to copy the complete details. So at this particular current directory, whatever is available, we are copying it into the working directory of our deployable environment. Then next step is to expose the application. So for exposing the application, we can define the port. So 8000 is our port, and the last step is the command in order to run the application. So we know that our code is there in app.py. That's our starting point of the application, and we just need to run. And the command is uvcon app. With the help of uvcon, we can run this particular application, and which is going to be served on port 8000. This simple it is to build the Docker file. So Docker file, what exactly it is? It is a set of instructions given in order to build your Docker image and Docker containers. So that's the simple thing. Now let's save this particular file. Now as our Docker file is ready, let me again give you the quick walkthrough. First, we are using a slim image from Python in order as a base image, on top of which we are creating a working directory. Then we are installing the UV as Python package manager, copying the requirements into there, installing the dependencies. Then we are copying the application code, and then we are just running the Python code. It is that simple. Now, first of all, if you have download the Docker desktop, let's open it. So I'm opening my Docker desktop. I might have some images already created, so I will delete those images and we will recreate it. Okay, so I have opened my Docker desktop. So currently there are images that are available. So let me go ahead and delete it. First, let me delete the runnable containers. Let me clean everything and we'll start from scratch. Let me also delete the images. Okay, so we don't have any container, no images available. Now we will be going ahead and creating an image. So as the Docker file is ready, now next step is to build the Docker image. Now the commands are pretty simple. If you Google it, you will get the commands. Now in order to build the Docker, the command is simple. Or what you can do is, I have already prepared one deployment document. You can follow this. Once you added this particular file, once you have installed the Docker desktop, you can come to this particular file, open it in the preview mode, and you can refer this as a guide. So this is the deployment guide, where you will get all the details, like the local application we have already built. Now we are working on Docker image, then we will push it to the ACR, will then call the AKS service, and that's how we will serve the application. So the first step is Docker build, and to build the Docker, this is the simple command, docker build -t for tag, and we can give the tag. Now let's give the name. Okay, let's do that. So docker build -t, and let me give the name as invint. Invint is investor intelligence, so we are going to use short form invint, and then dot, which means whatever is available, everything it is going to go ahead and generate the Docker image. So if you see now, it is building the Docker image and it will perform several activities. So first, if you see, it has copied the code into the working directory, and now it will install the dependencies. So it has run the dependencies as well. Somehow I have run this particular image before. That's where it is picking those dependencies from cache, and it will complete this activity very soon. But if you are running this application first time, it may take close to 2 or 3 minutes in order to generate the Docker file. Now, if you see, the complete Docker file is successfully built, and how we can check that? Again, you can refer the document. Yeah, you can, in order to check that, you can hit the command docker images. Now you will see the Docker images created. So if you see, invent is the Docker image, tag is the latest tag, because we have not given any tag. So as we have not given the tag, so the tag is not available. Now that's where it has picked the latest tag. And if you see, the image was created 55 seconds ago, and the size of image is 1.27 GB, meaning the complete code is now accumulated into 1.27 GB, which includes the Python image that we are downloading. So that is also associated with it. Now, as the image is built, now we need to run this particular image as a Docker container. So if I open the Docker desktop, and under containers, if you see, there is no container available. But if you go to the images, this image is created, and currently this image is not running. So in order to run the image, we need to go ahead and execute a command docker run. And after this, you can give a port, let's say -p for port, on which port you want to run this particular application. We know that our application runs on 8000 port. So you can give 8000, and then you can give the name in int. Now, again, you will get those details on this particular document. Now, the thing is, this 8000 and this 8000, how different it is. Now, this 8000 meaning where the application will run, where the application will be exposed to, and from which port it will be, uh, exposed. So basically, this is the port routing. This is our local port. From local port, we will be exposing the application to the 8000. I'll show you that. So first of all, let me run the application. So if you see, first it is saying that, okay, not able to find the image because there is a small spelling mistake. So int, and this will run the Docker image. So if you see, now it is running the code. Now, if you are able to execute this particular command, and if you are able to run the application, which means we have containerized our application. It is that simple. And if we are able to containerize the application, meaning now we can ship this particular container to any environment. So if you see, the application is running on 8000 port. So we can go to, so let's go and check on the local host 8000. We should see the application up and running. Okay, you can see the application is running, up and running. Now, no need to test. We already tested this application a couple of times, but you can see the revenue and other information is available. The chatbot here, it is available. So everything is working. Now, as it is exposed on 8000, right? So let me show you the porting part. So let me interrupt it. And if you see, instead of 8000, if I mention 8080, and if I run, so 8000 is our local port from which the application will be exposed to the port 8080. Now, if we go ahead and let the application run first, and now if we go ahead and run the localhost on 8000 port, it will not work, because now we have exposed the application on 8080. So if I hit this, it will throw an error. Okay, you can see, but the moment I change it to 8080, it will start running the application. Okay, you can see, the moment we switch to the 8080, the application is up and running. So that's how the port routing is done. Now, if I go to the Docker desktop and show you, under the containers, you will see the container that is running. So if you see, this is the container which is running on port 8080. Earlier it was on 8000 port. So that's how it is. So for the simplicity purpose, let's run the application on 8000 port itself. Okay. Now, this particular application, we have containerized it. Now the next step is we need to ship this particular container, and for that we need an, like what we have done is we have tested the Docker in local. The application is running, the Docker application is the image that we have created, right? It's running in local environment. So we need to push this image now. Now, as this image is available in our local, how do we make sure that this image is accessible for our production environment and or for our deployment environment? So in order to grant that access, we need to use one service from Azure, that is Azure Container Registry. So if you go ahead and check what exactly is Azure Container Registry. So if you see Azure Container Registry, simplify container lifestyle management, which builds, store, secure, scan, replicate, and manage container images and artifacts with fully managed geo-replicated instance. Meaning, this service helps us store your image, and it also makes sure that it serves that particular image. It registered the image, and then it basically serves this image for the services wherever it is required. So this is the place where our image is going to be available. So image in the sense a replica of our code will be available on this particular ACR. So let's go ahead and create this ACR service. I'm going to my Azure portal, and the way we created the initial services earlier. So if you see these services we created in our part 3 video. So if you have missed that, go ahead and check out the last part. So you can click on create, and here you can search container registry. If you search container, then also you will get the results. Okay, this is the container registry. Let's click on it. And again, it is pretty simple to create the registry. So let's click on create. Resource group, let's select the existing resource group. Name, let's give name as Inv Intelligence. It doesn't accept the spaces, so let's give the name Inv Intelligence. I would recommend you also follow the same nomenclature if you are following this particular video along with me. That way you'll be able to use the deployment document that I have created, and you will be able to copy paste the commands. Then let's select RBAC registry, and next, no need to mention anything else. Let's click on review and create. And once the validation is done, we can go ahead and create it. So that's how we can quickly create the Azure Container Registry. Okay, you can see the deployment is going on. Meanwhile, so this part now we have created the registry. So we have created initially we have registered this particular image into the local, and we have tested the application. Now we have created the Azure Container Registry, which is this step. So this particular part is done. Now whatever image that we have created, we need to push it to the ACR, that is Azure Container Registry. So in order to push that, let's go ahead and check whether the service is created first. Okay, service is created. Now first of all, you can go and under the access keys, you will get the details like the username and password and registry details. If you see, you have registry name and login server. Just click on admin user for now, so that you will get a username and password through which you can log into the Azure Container Registry. Now we are following this particular now we are using a password based authentication here, but ideally in industry most of the time we use a managed identity access. So we create a managed identity, and through managed identity we grant the accesses. But for now, let's keep it simple, and maybe if you guys are interested, I'll cover those parts in the upcoming series video. So let's go to the terminal. Let's terminate this, and let's do Docker images. Let's see how many images that we have. So currently we just have one image in int. So first step is we need to connect our service to the ACR. So before that, we need to connect to our Azure portal. So use AZ login. First time if you are running AZ login, you will get into the issue that maybe AZ is not recognized as a command. In that case, you will have to go ahead and install the Azure command line interface. So you just search on internet, and you just search on Google, and you will get that detail like, okay, AZ login. So I'm selecting my account and continuing, and it will basically pull my subscription. So this is my subscription iTech. I'm hitting enter. So again, iTech is our YouTube channel. If you have not subscribed yet, please go ahead and do that. Okay, so you can see we are able to connect to the AZ login. Now, if I do AZ ACR, right? So if you see example, it is giving, meaning following commands are required, sub commands and all. So we will be using AZ ACR command in order to connect now. Now AZ stands for connecting to the Azure. Now ACR is going to be the one service available on the Azure. So this is the managed service, and that's where in order to connect to the managed service, just like we use git push, git pull, that's where we are using AZ and then ACR, because this particular service is available under Azure. So if you scroll down, this part we have already tested. Now AZ login we have done. This is not required. We have already selected the subscription. So in order to log in, if you see, this is the command AZ ACR login -- name and the service name. So let's go ahead and quickly do AZ ACR -- login. sorry, ACR login hyphen name, and then the name of our registry. So this is the name of our registry. Let's go ahead and add it and let's hit enter. So with this, now it will connect to the ACR. So we should get a success message. Sorry, there is spelling mistake. ACR. Okay, you can see login succeed, meaning we are able to connect to the Azure Container Registry. Now, next step is as we as this individual user connected to the Azure Container Registry, but what we need to do is this particular image that is available in local, we need to push this particular image to the Azure Container Registry, and for that we need to grant access to our Docker, so that our Docker should connect to the ACR and push this particular image. Now, in order to do that, so if you see, this is the command that we will be hitting. So if you directly use this particular command, docker login, and this is our ACR. Now from where you will get that? So if you write docker login and if you go to the Azure services, this is the login server that we have. You can copy it from here, or you can go to the overview, and from here also you can copy it. Now you can paste that. Now this way we are connecting our Docker to the ACR that we have created. So let's hit enter. So if you see, it is asking username and password, and that username and password you will get it from this access keys section. So from here you can get this as a username and this as a password. But if you want to extract those details directly here, that's where you can run this particular ACR get credential. So if I'm terminating it and if I'm using this particular command, ACR credential show name for this particular ACR that we have created, investor intelligence. So if you see, we have password and all the details available, username and the password. So let's go ahead and hit this particular command again, docker login and username. So let's use this particular username and let's pass this password. Now it should again return a success message. Okay, you can see login succeed. Now our Docker has access. This Docker has access to the Azure Container Registry. Now we can push this particular image, but before pushing it, let's segregate the image that we have in local. We can create a new image, which is going to be the replica of existing image. And once we create one image, we can easily create new image by tagging it. So if you are aware about the tagging concept, which means you can just create a new replica with different name. So that's what we are going to create. So if you see, we are able to log in it. Now that's where we are going to assign a tag. So in order to do that, the command is docker tag, from which image we are going to create new image. So let me clear the screen. So if you see docker tag, int is our image that is available locally. So for example, if I show you docker images, int is our image with latest as a tag. So docker tag int colon latest, meaning this particular image, use this image and create its tag. Okay, so this is the local image that we have, this particular image, out of which we need to create a tag. Now the tag name is this int colon v1. Like int is the image name and v1 is the version. That's how we maintain. Every time we create new image, we maintain the versions in the real project whenever we work on it. And then what exactly is this? We are going to create this image on this particular ACR that we created, not on local. So if I do not pass this particular part, it will create the image in local. That's where we need to pass this. So on the ACR server, create a image with this particular tag. So if we do this, and now if I do the Docker images, still the image is in my local. We are going to push the image to this particular Docker, this particular ACR server now. So if you see, new image has been added, and if you see, the image ID is same and the size is also same, meaning we have used the same replica with new tag. Now the next part is we need to push this particular image. So this is the expected output that we obtain. Now in order to push, the command is very simple, docker push, and then you can give this particular name. With this, it will go ahead and push the image. So let's go ahead and hit enter. Okay, I missed to give the tag, so you will have to give the tag as v1. Okay, you can see it has started pushing. Now, if you are not able to log in initially, if you face any issues, then this particular command will definitely fail, because here now this 1.27 GB image, you are pushing it to the ACR. Now, ACR is a service, managed service from Azure, which will register this particular image. And from there, we can consume that particular image into our AKS cluster, Kubernetes cluster. So let's wait for this particular image push. Okay, you can see the image has been pushed, and now the image is available on the ACR. So let's go ahead and check out. So under the ACR, if you go to the activity log, you will be able to see we have done the recent push. So you can ignore the previous one that I have done as part of testing. But if you see a minute ago, we have pushed this particular image. So create or update container registry. So that is successful. So we are able to push the image. Now next step is, as this part is done, so if I go back to the application again, so this part is done, we have pushed the image to the registry. Now we are at this particular stage where the image is pushed. Now let's understand this particular diagram. Now the next step is to build the AKS cluster. Now Kubernetes, if you are new to the Kubernetes, so Kubernetes is basically, so if I take you to the AKS site, so Kubernetes is basically an open source service which was developed by Google, introduced by Google, and then later on the other cloud services adopted it. So what exactly it is? It deploys and manages the containerized application at scale, meaning this Kubernetes helps you deploy as well as manage your containerized application. Containerized application, we have already containerized our application and we have stored that into the AKS now, ACR now, Azure Container Registry. That is our containerized application. So this helps us deploy that particular application. Deploy in the sense it is going to provide the compute required in order to run your code. Plus manage in the sense whenever you basically deploy the application and whenever actual user starts using it, you need an management in the sense if the load on the application is increasing, you will have to manage the service, you will have to scale up your service. So that management is going to be taken care by the Kubernetes service, and the Kubernetes service that is available on Azure is AKS, Azure Kubernetes service. So that is what we are going to use. So if we go back here, let's understand this AKS flow. So whenever user or clients hits the request, means whenever a user asks, let's say we have a endpoint, the way we had local host endpoint 8000, right? Similarly, let's say we have one investorintelligence.com as a website. So whenever user hit that particular website from a internet, first the request goes to the Azure load balancer. I'll talk about Azure load balancer, what exactly it is. Then the request goes to the AKS. Now the task of AKS is to serve this particular API request, and that's where it creates the API server. Then it has scheduler, control manager, the cluster DB, cloud control manager. These are the control panels on AKS which takes care of your management of the application. And then the rest of the other services that we have with respect to the AKS, which are helpful in order to manage it. So this is not again AKS class. If you search about these services, you will get to know about these services. Then next part is node pool or worker nodes. So what happens is whenever the application is available, what happens is once let's say we have the application, so it creates a node. For example, let's say we have a and this nodes it creates the node. Node is nothing but the replica of the instances that we are deploying. So for example, in one node you can have multiple pods, and each pod basically, so what node does is basically it provides the resources required to run the pod. Resources in the sense it provides the networking, it provides the memory required, it also provides the CPU, right? The compute power that is required in order to run the application, that is provided by node. Now let's say, and why multiple nodes are required? Let's say if your one node is not sufficient to serve the request, then we go to the multiple nodes. But let's understand the first nodes and pods there first. So the difference between these two is nodes is basically in order to provide the resources, compute power, memory, networking, and pods are the consumers of that particular. Like pod actually consumes the compute resource provided by node. It actually uses the networking. It actually uses the memory. So that's the task of pods where your actual container runs. So actual container runs on the pod. Now what happens is that, let's say this node 1 is, let's say, your 16 GB machine, and whenever user asks a question, first of all, let's say you will have multiple pods. So pods is nothing but your replica of running instances of your container. So first, let's say the request will go to the pod 1, for example. If pod 1's memory is full, or in case if there is any issue with the pod 1, if the pod 1 is down, then the node 1 can make sure the pod 2 and pod 3 are available to serve the user, in order to avoid the fluctuations at the user end. In order to avoid the bad user experience, it makes sure even though any of the pod goes down, the rest of the pods will take care of it. Now then you might ask questions, why do we need multiple nodes? For example, let's say you have, currently we just have one microservice, right, that we are deploying. But let's say if you are segregating the UI and backend as a two microservices, so what will happen, your pod 1 can run first microservice, first containerized application. Pod 2 can run your second containerized application. So what it does, uh, for example, in this case, we just have single microservices, a service created. So, but ideally what happens, in your application, you may have more than two microservices, and each microservices, we consider it as a one container application, one containerized application. So these pods are responsible to handle those containerized application. Let's say this is handling UI, this is backend, this is some cache, something like that, right? So that's how the pods are required, different pods. And why then multiple nodes are required? For example, whenever, let's say, 100 users are coming to our application, then what this load balancer will do, load balancer will allow those users to talk to this particular AKS. So it will just send the request to the AKS. And it also does some management of load. So if you see, the task itself is load balancer, meaning it balances the load of application. It detects, let's say, if the service is flow, the users are serving through the node 1, and suddenly instead of 100, let's say 1000 users are coming in, and this node is not sufficient to handle the load for 1000 users. In that case, this load balancer will migrate the traffic to the node 2 and to the node 3 likewise. So let's take an example of Hotstar, for example. Let's say before starting a IPL match or any match, let's say the number of users are, let's say, 10 lakh. So 10 lakh users can be served through node 1. But the moment the match starts, the moment they announces the toss, you can see the traffic starts increasing, and in that case your node 1 might not be sufficient. So in that case, this load balancer makes sure your node 2 is available to serve the new users that are coming in, and similarly to the node 3. And there is auto scaling mechanism. If you enable that auto scaling, it will keep increasing these nodes, so it will keep horizontally scaling the application. So no matter how many users are accessing your application will work smoothly. And that's where these applications like Netflix, Hotstars, right, they work seamlessly without any issue. Even though millions of users are coming at a time to the application, this particular system of auto scaling and node and pods takes care of handling this particular load with the help of load balancer, in order to give the seamless, in order to give a smooth user experience. So that's the AKS. And now this AKS can also connect to the external services that we have, like we have Azure AI Search, Open AI service that we have. Then let's say the server SQL that we have created, the PostgreSQL. So it can connect to these another services that we have on Azure. Now let's go ahead and start working on it. So first of all, we'll have to create the AKS. So let's go to the Azure portal and click on create. And here let's search Kubernetes. This is the service, Kubernetes AKS. Now let's click on create. Let's select the existing resource group. Dev test is fine. We are doing it for the testing purpose only. Name of Kubernetes cluster. Let's give the name as Investor Intelligence AKS. Region is fine. All those details are fine. Let's select free only. And these other details you can keep it as is. Let's click on next. Now here you need to create a agent pool. So the default agent pool that they have given, it is a 2 to 5 node count with 110 max pods it can create. But for us, I think it's, if you see, it is not going to fit into my subscription, so I'll have to request a quota. So instead I will delete this and I'll click on add new add node poll, and I'll click on this first one, and here let's give the name as, let's say, int node, and let's click on mode as system, and zones, we don't need any zones, so let's deselect it just in order to save the cost. And here let's select manual. We are not going to enable the auto scale. So I mentioned, right, auto scale, which will keep scaling your application. It will keep adding the nodes. And here you can set, even though if it is auto scale, what is the maximum count of threshold you want to add, so that you can stop the increment of the nodes in order to save the cost and all. So let's not select that. Let's select manual, and here I'm giving 2 nodes only, which is again more than enough for our application. But just to show some details on the practical stuff, I will select 2. You can select 1 node as well. And then here we need to select the size. So let's click on choose, and multiple sizes are available, out of which we will select one size. So let it load. Again, it is a costly service. So if you see, the charges are $65 per month. So you can select a service which is having less cost. I'm going ahead with the first one. So let me select this, which is going to create this 2 virtual CPUs and 4 GB memory it is going to create. So which is sufficient for us. Let's click on add. I'm selecting this review and create. Hopefully it should not give any error, and we will go ahead and create the service. So the validation is going on. Okay, validation is completed. Let's click on create. Now this service creation takes a quite time. It may take 4 to 5 minutes for you to create this particular service. So let's wait for that service creation, and once the service is created, I'll come back. Okay, as you can see, the service has been created, and it created a lot of details. So if I expand this, right, you can see it has created these many details. So even though you have just created the investor intelligence AKS service, but behind the scene, whatever other services, supporting services that are required, it goes ahead and create it. Now let's click on go to resource, and okay. So from this particular service, now the next task is how we are going to build the connection between the AKS and the ACR, because our image is available on the ACR, right? And our AKS service is here. So we need to build that connection. So if you see this particular part, we should give permissions for the AKS service to connect to the ACR service and pull the image. So this pull image now we are going to work on. So let's get started on it. So again, I'm opening my code, and again you can follow the deployment documentation along. This part now we are going to start connecting to the AKS service. So you can check this. Whenever we have pushed the image, later on you can check whether the image is successfully pushed or not. But let's skip it for now. It's not mandatory. You can go ahead and run this particular command now. So the way we were using ACR command for connecting to the Azure Container Registry, now the command has changed to AKS, Azure Kubernetes Service. So the Kubernetes service is available on Azure. That's where AKS, just like our GitHub or Docker, we use Docker push. Similarly, it is like this AKS. And now first we need to get the credential. Now the what and all details that we'll be requiring is resource group. So the command is pretty simple. AKS get hyphen credentials hyphen resource group. We need to give the resource group under which this particular service belongs to, the name of the AKS service, and overwriting equals to existing. So if you go to the portal again, and this is our resource group. So if you see, this resource group is matching to this command, and that's the reason I mentioned you can use the same nomenclature, so that if it is available, or else you will have to change these names. So the resource group is RG Inu Intelligence. That's what is the resource group. Inu is the investor. So we can directly use this command, and the name of AKS service is again same. So if you see investor intelligence AKS, so we can go ahead and use this particular command. So okay, if you see AKS get credentials, so we are getting the credentials. So let's hit this, and that should help us connect to the service. So if you see merged investor intelligence AKS as current context, now how do we make sure that we are into the service? We are already connected. So for that, now we are going to use the commands. Now these commands are a bit different. The way we use commands like git push, git pull, right? Those commands. Similarly, for you hitting to the Kubernetes service, we use kubectl as a command. Kubectl is a Kubernetes command line tool in order to connect to the Kubernetes, and we can validate this. So kubectl, this is the command kubectl, and get, and then you can click on nodes. So the moment you do this, oh sorry, kubectl get nodes. So if you remember, we selected two nodes while creating the service. So these are the two nodes that are available. Now, if you go back to the user interface, if you go back here, and this is the part that we created now. We created these two nodes now, and these are the fixed nodes. We have not enabled the auto scaling. So the nodes size is going to be remain fixed. So if our load increases beyond beyond the capability of these two nodes, our application will start crashing. But currently, just for the study purpose, we can keep it to the two node, and that's the reason I wanted to show you. So these are the two nodes that are available now. If you see, just the nodes are there, but we have not created any pod yet. So these pods are not there. So if you see, and if you use the command kubectl get pods, you will not see anything because we have not created the pods yet. So if you see, no resources found in default message. So again, the commands are pretty simple. If you Google, you will get those commands easily. Kubectl get pods in order to check the pods that are available. So first thing is we need to okay. So before jumping to the pods, we need to first connect to the ACR. So we need to verify whether our AKS, the Kubernetes cluster, can access the container registry, and for that we have this command. So you can use this command. AKS update command is in order to connect, is in order to update the service to access the ACR. So hyphen resource group, this is our resource group, hyphen name, this is AKS service, hyphen attach, this is the name of our ACR. If you remember, in intelligence, that is the ACR name, the Azure Container Registry name. So if you hit enter, most probably it will fail. Oh, okay, sorry. There's some extra line that was added. So most probably this will fail. If you are running this command first time, there are high chances it will fail. So let's see. If it fails, I will talk about why it fails and how we can fix that error as well. Because our ACR, which is a Azure Container Registry, available on Azure, and our Kubernetes service is also available on the Azure, and these two services should have a communication between them. Okay, so as I have done the easy login, and both these services are under same subscription, so that's where I did not face this issue. But in the upcoming commands, we will face that issue, and I'll show you how we can enable that communication channel. So currently, it's printing this particular part. So it is in progress, so it will take close to 2 to 3 minutes in order to connect to the ACR. So with this, now we are forming a bridge between AKS and ACR, and that is what we have showcased here. So this bridge now we are connecting between ACR and AKS, so that whenever required, AKS can hit to this particular container registry and pull the image that we have pushed to that particular container registry. Now the deployment that we are doing is the manual deployment, and in the next video I'm going to cover the automation, deployment automation as well, with the help of GitHub Actions. So we'll be using a CI/CD pipeline through which it will go ahead and deploy the application. So in the CI/CD, like whenever you push your code, the continuous integration will pick up that particular change, and continuous delivery will deploy the application, and that's how your application will be available, or your new changes will be available for the end user. So that is what again we are going to cover in the next video. So please stay tuned for that video as well. But for now, I just want to uh, go over the flow that is required, how the deployment works, what are the steps involved in the deployment. See, deployment is not like deployment is a very important step, but most of the people gets worried if they heard the word deployment, they get scared. But there is nothing to scare about. It's pretty simple. If you are following this particular tutorial till this point, meaning now by end of this particular series, you will be very confident to deploy your applications as well. So trust me and just keep following this particular series. So this is again still it will take some time. So let's hold on, and once this particular step is completed, we'll come back. Okay, you can see the command was successful. Now we just need to check whether really the AKS is able to access the ACR or not. For that, you can use this verify access command again, which is pretty simple, just like the above command. Now instead of update, we are using AZ AKS check ACR command. Same thing, we are passing the resource group, the AKS service name, and we are passing the ACR service name. So let's go ahead and hit enter. So this, if this returns that it was able to pull the image successfully, meaning we were able to build the connection. But if it fails, we will fix the issues if there are any. So let's wait for this. It should return at the end the image pulled successfully. So this is the expected output. Okay, your cluster can pull images from the in intelligence Azure, this particular one, that is our ACR. So okay, this is working fine, meaning the connection is successful. AKS can now pull the image from ACR as well. Okay, so now the next step is to pull the image from the ACR, the container registry, and then we can basically create the pods and we can start the application. So this step is there. In case if this image pull fails, then you can follow this particular steps where first you get the credentials of your ACR and then you use this particular command. With the help of username password, you connect to the service. But if you face any issues, then only you follow this step. Else you can skip it and you can directly come to the deploy application. Now in order to deploy, first you will have to create the deployment. Okay, now let's work on the deployment. Again, for deployment the command is pretty simple, create deployment. So kubectl create deployment, and then we need to pass the deployment name. So deployment name, again I'm going to keep it very simple, int, this is the deployment name, hyphen hyphen, we just need to pass the image. Now we already know the image that we created on ACR, so this is our image with the tag, so we can just pass this and let's hit enter. So this will create the deployment. So if you see, deployment is created. Now the moment we hit this, now it has created these pods inside these particular nodes. It has created those details. So if you want to see, now you can hit the command kubectl get deployment. So if you see, int is the deployment which is in the ready state. Now let's check kubectl whether it has created the pods or not. Get pods. Okay, you can see it has created this pod. Only one pod it has created, and if you see, we are getting error in pulling the image, and this is what I was talking about. So though it return your container can your AKS can pull the image, but there is one problem, I'll talk about it. So this particular pod, it is failing to load. Now in order to see the actual error, you can again hit the command kubectl, then you can use this particular, you can use log command, log, and then you can pass the pod. Sorry, it's logs, kubectl logs, and you can pass the pod. Okay, so if you see error server, bad request in int in pod is waiting to start. So trying and failing to pull the image. So it is not able to pull the image. Now in order to do that, you can go to the service. So the problem is this particular service, it is not able to pull the image from ACR, and for that you can go to the ACR that we created. So go to the resource group. So this is our resource group, or the resource group it has created by default, and this is our ACR container registry. Now from the container registry, so first of all what you need to do is uh, you can go to the access control and click on add role assignment. We will have to add a role for our users to user to access, pull and push the image. So you can click on ACR pull next, and you can select the member. You can select the user for which the access is required, select it, review and assign, and you can assign it. Similarly, you will have to do it for the role is I have already added, that's where it is filling. Similarly, you can go ahead and add the role for push. So if I'm now adding for push, So select ACR push, next, select the member, select it, review and assign. So the problem is our AKS is not able to directly pull the image. So what we need to do is we need to use the steps that I mentioned to skip, right? I think ninth or eighth step. We will have to use the same steps in order to connect. So if you are also facing that issue, you will have to do that. So again, if you go back to the deployment steps, so this step 9, we will have to do it again, pull the secrets. So for that, let's use this particular one. So now if you see, I have added the two roles, and if I see view my access, I should have ACR pull, push these particular roles. Now, if we use this particular command, the ACR credential show, it will show the credential for this particular ACR again, and we can use those credentials in order to hit this particular command. So let's use this particular command in order to create the secret. So first we will create the Kubernetes secret, and through that secret, then we will patch the service. So with the help of this username and password, the AKS will connect to the ACR, right? So because these username and password are for AKS, for ACR. So let's use kubectl create secret docker registry. ACR secret is the name of secret that we are giving. Hyphen hyphen docker, we need to give hyphen hyphen docker username, and let's pass the username. This is the username we have that we have used. Then hyphen hyphen docker server, we need to pass the docker server. So this is the server that we have for the ACR. So let's use this as a server, and then hyphen hyphen docker password we need to give. Docker hyphen password equals to, let's select this as a password, and once you hit this, now this will make sure it will connect to the, so if you see, the secret is created. Now we have the secret. Let's patch this secret. So our Azure Kubernetes service is going to use this secret in order to connect to the Azure Container Registry. Now again, uh, this is, we are doing it with the help of password, but most of the organization follow a managed identity approach. So they give access to the managed identity so that one service can talk to the another service which are available under the same tenant. So that's how, or under the same subscription, that's how it works. So for now, the patching command is this. So you will get that command as well. So if you see kubectl patch service account, and this is the default image pool secrets we are using, and this is the name of secret that we have created. So before executing this, if I want to show you kubectl, let me clear the screen. Kubectl get secret. So if you see, this is the secret that we have created, ACR secret. This is the secret that is available. Now let's use this command in order to patch the secret. So kubectl patch service account, and we have passed this as a secret. So with the help of this username and password, so if you see, the service account has been patched. Now we should be able to execute this command. Now again, let's recreate the deployment. So first of all, let's check kubectl get deployment. So we have this as a deployment in int. So if you scroll down, you will get a command to basically reload the deployment. So this is the command in order to roll out the deployment again. So here, with which we can restart it. So kubectl rollout restart the deployment. So we have done that. If you go and check the deployment, so we have the deployment. Now as the deployment is ready, next step is to check the pods again. So in order to check that, first let's check kubectl get pods. As we have restarted the service, it will create new pods. So if you see, these are the pods that it has created. Let's check the logs, kubectl logs, and then we can paste the pod. So this is the pod that we have. You can see container creating. So this was the earlier pod that we created, and which was where we faced the issue that it was not able to pull the image. But now if you see, the status is container creating. So let's check the complete log, whether our application is running. Okay, you can see on this particular pod, the new pod that we have created, on this pod the application is running. Okay, so this application is now running on the deployment environment. So if you go to the localhost and hit this, right, you will not see the application will not run. So if you want to try it out, you can go ahead and try this on the local host 8000. It will not work because the application is running on the AKS cluster, not on our local. Now, in order to serve this particular application, what we will have to do is we will have to basically expose this application. And for the exposure, again, you will get the commands on this. If you see the step 13, expose the application. So for exposing, you can copy this. So the command is pretty simple. Let me terminate this, clear the screen. kubectl expose deployment in int. This is the deployment which we are basically exposing. Type is load balancer. Remember now, we have enabled a load balancer which will make sure to manage the load across the two nodes that we have created. It will not create new node, but it will manage the load between these two nodes that we have created. So the part that we saw, right, this load balancer, that's what we have defining. Then port 80, this is the exposure port and this is the internal port of the application where it is running on AKS. So from that reroute to the port 80. So let's execute this command and it will expose the application. So if you see now the service is exports. So you should see a public endpoint now. Now if you go ahead and do kubectl get svc stands for service, you should be able to see two services. Okay, if you see, first is the service from the Kubernetes, which is cluster IP, which is the default service that Kubernetes creates in order to manage the internal services, right? And basically whatever commands that we are hitting, right, creating the deployment and all, in order to manage that, it creates one service. And second service is the one load balancer of type load balancer which we created, and this is the external IP on this particular application. On this particular IP our application is running. So if you copy this and if you go to the user interface and now if you type this and hit enter, it should open our application. If there are no issues, it should open the application. Okay, it is failing, so let's figure out what's the issue. Now here you cannot see the issue, so in order to check that, again you can go kubectl and you can use logs. Now use -f, or before that we'll have to use kubectl get pods to get the pod ID, and then kubectl logs -f and then copy this particular pod and let's see what's the problem. Okay, there is no problem, then why it is failing? Let's go ahead and double check. Let's reload the application. Okay. Okay, you can see the financial intelligence already exists. So it has created the table. Table creation is successful. Now I think it should work. Let's refresh. What's the problem? Oh, it is hitting to the HTTPS. Just change it to HTTP and then it should work because our application is running on HTTP. Okay, cool. You can see it has loaded the application. Now this application is working on the public IP. This is not secure because it is a HTTP. In order to make it public IP, again, we will have to go through the, we will have to first purchase the custom domain like, okay, AI powered investorintelligence.com or .in, something like that. Then, and then we will have to use a ingress in between in order to make it public, in order to make it secure. But that is not the scope of this particular video. So if you are still doubtful, I'll go ahead and open a incognito and from there I can run the service. Now n number of users can go ahead and access this particular service. Let's continue to the site and they can easily access the application. Now if I share this ID with you, right, you guys can also able to access this particular application. So that's the power of deployment. Now as the deployment is completed, unfortunately I cannot share this because it incurs a cost, and post this particular video I'm going to delete the services that I have created. So unfortunately you guys will not be able to access this. I really wanted to share this, but trust me guys, because of the cost issues, I cannot do that. But yeah, along with me you guys can get the feel of how the deployed application looks like. So this is how it is. Now you can see no localhost, nothing is there, so the application is accessible to all the outside people. Now if we come back again here, one step I missed is you may face issue if you go to the homepage, and if you go to the PostgreSQL that we have created, you will have to enable the public access for this, because that way only our Kubernetes service will talk to this particular service. So if you go to the networking, and under the networking you will have to allow this checkbox, you will have to allow public access from any Azure services within the Azure to this service. So whatever services available under this particular subscription, they should be able to allow access this particular application. So that's where you will have to select this, and once that is done, then that's it. So you should see the application. But still, if you face any issues, right, while creating the service, while accessing the application, while running the Kubernetes command, while running the ACR commands, please feel free to reach out to me. Please let me know in the comment section. Now let's test the application. Let's click on uploading the file, and Apple is there. Let's upload the Tesla file. Okay, you can see uploading the report is going on, and same logs, then you can go ahead and check here. So if you see here, it will print all the logs. So it is still uploading the report. So once the report is uploaded, it will refresh this particular user interface, and end-to-end application is now working. Okay, you can see the Tesla has been updated successfully, and you can see the records are available. So that's how the application is working in production. And let me show you the chatbot as well. So on the chatbot, let's select the company Tesla, and let's ask the total net income of Tesla in the year 2024. What is the net income of Tesla in the year 2024? Let's ask this question. Okay, you can see the Tesla's income for the year 2024 is 7.153. So that's matching this particular number. So that's how this particular application is working. And I hope you were able to understand. I hope you were able to grab all the details. I hope you understood the process of how this particular application is working, and how we can deploy this application with the help of the Azure cloud services like Azure Container Registry and the Azure Kubernetes service. So yeah, if you really like this particular video, go ahead and like the video and subscribe to the YouTube channel. Specifically, I have added this particular one so that you can go ahead and like and subscribe to the channel. So yeah, in the next video, as I mentioned, we will be going ahead and creating an CI/CD pipeline, end-to-end CI/CD pipeline, and with the help of GitHub Actions, we'll be triggering those pipelines as well. And that's how we will be automating this particular complete deployment journey. And that's where we no need to manually go ahead and write these commands to deploy the application. But yeah, this was a brief overview so that you understand how the deployment works, what happens behind the scene when we always talk about the AKS deployment or Kubernetes deployment. So same way the other deployment also works. So in the last video, we have covered the manual deployment, right? So we have hit too many commands in order to connect to the services, and then we have connected to the multiple services, we have pushed the changes, and many more things that we have done. Now that was the manual way of doing it. So to understand the process of deployment, that's a very good way to go ahead about it. But in a real industry, that manual deployment doesn't work. What happens is, you cannot keep deploying the application manually, right? Like in the real industry, the changes to the application happens over a week or over a sprint by sprint, and at the end of every sprint, or based on your deployment schedule cycle, you keep pushing your changes uh, to the production so that your end user can consume that. And in those cases, your manual deployment becomes a hectic. You can deploy that application one time, but who is going to be responsible for running the same command again and again? And that's where we use a CI/CD approach, continuous integration, continuous delivery, in order to automate the deployment. And how exactly it works, let's understand that. So as you can see, CI/CD, it is like divided into two parts. First one is the CI, and second one is the CD. Now in the continuous integration, we have code where we actually put our code. Then we do the planning in the sense we decide what and all things that we need to perform in order to deploy the application. We build in the sense we build the Docker image, right? That we have already seen. And continuous integration falls into both, because once the continuous integration is done, so the continuous testing is part of it itself. Like it test the application, and if the application is good, if the test cases are passed, then it goes for the deployment side. And in the deployment, what we have is again build, operate, deploy, and release, meaning it consists of multiple stuff. Like once the application is deployed, then we serve that application to the user. And again, this deployment cycle is managed by the deployment services that are available, like the one we are using, Azure Kubernetes service. So let's understand how this CI/CD pipeline that we are going to build for our project. So we will be using an GitHub Action. GitHub Action again is a very good tool available from the GitHub in order to automate these, uh, the deployments, and how exactly it works. We are going to see that in depth. So first of all, let's say we have completed our code. The first version is ready, and you have, let's say, done a manual deployment, for example. Now the application is available for end user. Now next time, whatever new changes the developer is working on, that code change, this developer push it to the repository. Now whenever developer push that changes, what happens? That change goes to the GitHub repository. In the same fashion, we have the same approach. Whenever we are going to do any code change, it will go and append that data or append that code into the GitHub repository. In that GitHub repository, we are going to build an CI/CD setup. So we are going to create a CI/CD setup in this GitHub repository. And whenever developer pushes any change to the code, this particular workflow that we are going to create, GitHub action workflow, it's going to basically get triggered. So the moment a new change pushed to a particular repository, it will trigger the workflow. And that triggering, what it does, it checks out the code, then it builds the Docker image. Now, earlier we have built the Docker image manually, but this particular GitHub action workflow is going to build that image. It's going to log into the Azure Container Registry where we are going to keep our image. Then it is going to push that image to the ACR, update the Kubernetes manifest, and then deploy that particular code to the AKS. So this particular workflow where we are going to define these instructions, and then it is going to do the actual push. Then AKS is going to pull that particular image. Then we have built this particular node and pod based structure in the last deployment as well. And then we will have a service load balancer in order to serve the application to the end user. So that's the process of GitHub action. Like whenever there is a new change occurs, the workflow gets automatically triggered. It push the image to the ACR. AKS pull the image and it basically deploy the application, and that's how, with the help of load balancer, your final end user can access the application. So that's the benefit of using a CI/CD. Now, without wasting time, let's straight jump on to writing this particular workflow. So first of all, currently we are on the main branch. So this is our code repository. If you have not cloned the repository, I would recommend go ahead and check out that. The link is there in the description below. Now, so first of all, we are currently in the main repository. So what I'm going to do is I'm going to create a separate branch, and there we will test it. So let's create a new branch. Let's create a new branch from main, and I'm going to give the name as CI/CD. That's our branch. Okay. So currently we are in the CI/CD branch. Now first step is that we need to create the GitHub workflow. And what I have done is I have created a sample document. You can definitely refer this document in order to complete this CI/CD as well. The way I created the document for the manual deployment, in the same fashion I have created the document for this as well. Okay, so let me open this document in preview, and we are going to follow this document. So let me split it so that side by side we can see it. Okay. Now the first step is we need to create a GitHub workflow. So we are going to follow a standard way. Like we are going to create two folders. First, we are going to create a Kubernetes folder in which we are going to keep the YAML file or the YAML instructions related to the creating the deployment. So in the manual deployment document, if you open it, so in the last we have created the deployment, and so if you see deploy the application where we are creating kubectl create deployment, we are deciding how many pods, how many nodes and all that stuff right here. So in order to define that, we need to create a YAML files with respect to this, and then again we need to create one more YAML file in order to serve the application, that is in order to expose it. Now you can combine it in one file as well, but the different industry follows a different standard ways, and we are going to follow one standard way where we are going to create one folder first, a Kubernetes folder under which we are going to create those files, and under the workflow folder we are going to create a main file. Okay, so first of all, let's create the GitHub folder. So dot GitHub, under which we are going to give the workflow file, and under this let's create new folder. workflow, and under workflow now you can create a new file, let's say deploy.yaml. Okay, and also let's create one more folder. I'll give the name as KATS, that is Kubernetes, and under Kubernetes let's create a file deployment.yaml, which is going to create the deployment, and one more file we can create, that is service.yaml, in order to start the service. Okay, so we have created these files. Now let's start adding the code. So first of all, let's add the code related to the deployment. So I'm adding the code now, and we will review this code. Okay, so first of all, we are adding the API version. It is just the version. Kind is the deployment. And then we are adding metadata, name of the deployment, that is int. That's the name we followed while deploying the manual application as well. And here you can refer the documentation, what these each term mean. So if you see, again, I have added the complete deployment file as well here. You can pick the file from here. So first of all, API version that we have defined, what it does, it tells the Kubernetes which API group should this process belongs to. So it just gives the idea for the Kubernetes that in which API group this particular application belongs to. Kind equals to deployment, which tells what is the type of job that we are going to do. So here we are going to perform a deployment. So there are other jobs as well, like if you see there are deployment as available, then you can perform a service, secret, config map, ingress. Those are the different kinds that are available, out of which we are going to perform a deployment. Then next one, metadata name invent, which means it is a unique name of the deployment inside the cluster. So inside a cluster that we are going to create, we are going to create a deployment with name invent. Okay, next step, let me go ahead and add it. So next, let's define the specification. First, we are defining one replica, then selector, and in which we are adding app as invent. And again, you can go ahead and follow this document, what exactly it is. Like replicas meaning we are defining how many copies of this application should be running. And in development environment, we usually use one replica, but in production, we create multiple replicas so that if any one pod crashes, then you can go ahead and use the remaining pods. Then the selector, which just gives idea that, okay, each pod belongs to which particular deployment. And we know already the deployment is invent. And again, I'm adding bare minimum that is required in order to create the service. So in the last video, we created the service by writing the command, right? kubectl create deployment and all. So that all things are not required now. Everything will be taken care by these YAML files. Then next part is the template, where we can define the template. Now in the template, okay, so that template belongs to this particular specification. And if you see now what exactly that template is, so it is a section that acts as a blueprint used to create a pods. And again, we are not defining any further details. We are just defining the app name here. And this is going to be act as a tag for the pod. So whenever we will create the pod, I will show you, it will create a pod with name, tag name this. So this is going to be the tag name for the pod, and from where the container is going to understand this particular pod belongs to which particular deployment. And the next part is we need to add the specification. Now specification again is a very important part. Under the template, we are defining the specification. So if you see, name is invent, that is fine. Image, we are giving the image name. So if you remember, we have created a ACR service with this name, in intelligence Azure ACR.io in int latest. This is going to be our place where we are going to push our container registry image. So if you see now, image pull policy always. So this means whenever you are pushing any changes, so whenever you are creating the deployment or restarting the pod, it is always going to check whether there is a new image available at this location. This makes sure that your application consumes the latest image that is available or the latest code that is available, and it is not redirecting or it is not serving the old code. And then we are defining the environment details. So in the environment details, like if you remember in the last video, we have pushed the uh, environments along with the image, but that is not a standard practice. Whenever you are working on CI/CD, you need to make sure that you are adding the secret somewhere, maybe on Key Vault or maybe on GitHub secrets, and from there you are pulling it. So that's where we are going to create an environment with name int secrets, and this is the port on which the container application is going to run, not the final application, right, which we are going to serve to the user. This is going to be the application which is going to run under the container. So this is the simple file that we have created in order to create the deployment. Now this is just the deployment creation. This is not the actual deployment, right? It is just going to create the Kubernetes deployment service. So the thing that we discussed here, right, it is just going to work on this deploy application. Now the next is service.yaml. Under service.yaml, we are going to add the code which is related to the serving. And again, this code is pretty simple. So first of all, we are adding a API version. Now kind is service. So if you see now, earlier we defined kind as deployment. Now the kind is service. And then we have a metadata, which is again defining the name of the deployment, that is in int that we have defined. Then selector is in int, type is load balancer, because we are going to serve the user through the load balancer, and the task of load balancer and everything we have already studied in the last video. And on the port, we are defining the protocol TCP, which is a most widely protocol used in the industries, like which follows the HTTP and HTTPS protocol. Port is 80 and target port 8000, meaning this is the container port on which the application is running, and this is the port on which we are going to reroute it. So the user request will come to port 80, which then it will transfer the request to the port 8000. That's how the application is going to work. Okay, so we have worked on these two files. Now only one file that is pending, that we can directly go ahead and update now the deployment, where we are going to pull these two files in order to complete the deployment. And again, it is going to be pretty simple. So first we are going to define the name. So the name is build and deploy to AKS, and on push branches CI/CD. So let me change this to CI/CD, because we have CI/CD as a branch, meaning whenever you push any changes to this branch CI/CD, it will go ahead and trigger the workflow. On meaning it is a triggered point for your application, and you can again follow the documentation along. I have mentioned all the details here. So yeah, if you see, this tells GitHub when to execute the pipeline. Pretty simple. Then next, we need to define the job. Now the job, again, it is pretty simple. So in the job is build and deploy. That's our job, and runs on Ubuntu latest. Meaning what exactly it does, whenever you are running this particular, or whenever it is triggering the workflow, we are going to create a temporary Ubuntu latest machine in order to execute these commands. These commands in the sense, like we are going to add a command in order to connect to the ACR, in order to connect to the AKS. So in order to execute those commands, you need some compute, and that temporary compute is going to be provided by this particular Ubuntu latest. And you can again read about it. It creates a temporary Ubuntu virtual machine to execute all the steps, all the pipeline steps. Now the next part is we need to define the steps, and in the steps, the first part is we are going to check out to the repository. Now why this checkout to the repository is required? Because it downloads the source code into the GitHub runner, meaning whatever this runner is, it is going to pull the latest code available as part of this particular uh, run. So it is going to pull from this particular branch, it is going to pull the latest code, and that code then we are going to build the image on top of it and push it. Now next is you can directly build the image, but as we are connecting to the Azure services, right, like to the ACR container registry, then to the Kubernetes service, we are going to add those connection details with which we are going to connect to the Azure. So I'm going to add Azure connection now. Okay, so if you see, this is checkout repository is done. Next task is Azure login, where we are login to the Azure. And again, if you see, I have defined one secret here. So what exactly this does is, this secret, it picks the secret from the GitHub secret, and the secret name is Azure credential. And in order to connect to this particular service, we need to create an service principal, because earlier I was using my account, my user ID, and my personal subscription, my personal user ID in order to connect to the services like easy login. I was logging through my application, I was logging through my email. But now this GitHub, right, it will not use my login in order to connect. Instead, it will use a service principal. So whenever any application wants to connect to another application, there is no human involved in between. In those cases, we use service principal in order to connect. So service principal is going to act as a user, which is going to connect these two services. So first of all, let's go ahead and create a service principal. So I'm going to the application, and in order to create the service principal, search Microsoft Enter ID, and under which, if you see, you have a app registration. You can click on app registration, new registration, and let's give name as SPN investor SPN Investor Intelligence. And you no need to select anything else. Just click on register. Now this will create one application for us. Okay. So if you see now there are a couple of details that are pretty much important. So first, if you see client ID is important, tenant ID is important. So I'm going to copy it and I'm going to keep it on my notes. So let me add client ID. I will also add the tenant ID. Okay. And then once the service principal is created, we also need to create the secret. So in order to create the secret, you can click on certificates and secrets, and under which click on new client secret. And you can give the name as, let's say, GitHub connection, CICD, something like that. And then expiry 6 months, that's fine. Click on add. Now this will create one secret, and make sure you copy this secret value. The secret value is pretty important because it won't show this value again, and you can copy the secret ID. Not sure, I don't think it is required, but let's copy that. Okay, I have saved these two details into my notes. Now we are okay to use this. Now the thing that I mentioned here, Azure credentials, right? We need to add the Azure credentials, and these Azure credentials are in the format where we need to add these details like the application ID, client secret. Okay, now let's go ahead and add these secrets onto the GitHub secret. So let's go to the repository. So I'm into my repository. This is our repo. Let me open it, and then you can go ahead and select the branch. Okay, we have not pushed the changes, so you can click on settings, and you can click on secrets and variable. I have already added the secrets. I'll just show you how you can add it because there are multiple secrets. So if you see this client Azure credentials, click on edit, and under this we need to pass the value. So whenever you come to this particular secrets, if you want to add any secret, you click on new repository secret. Make sure you add that under the action. Give the name like the Azure credentials that we mentioned and add the value. Now I'm going ahead and updating this secret because this is pretty old secret. So Azure credentials, and then here I am adding the value. Now this value should be in this format. We should add client ID, client secret, subscription ID, and the tenant ID. So first of all, let me go ahead and add the client secret because that's what I have copied. So okay, so I'm adding the client secret here. Then next one is the client ID. You can again go back and click on overview. This is our client ID. Let's copy it and let's pass it here. Then next we have subscription ID. Subscription ID, you can get it from the any application that we have created. Maybe you can go to the resource group and from there you can get it. See, this is the subscription ID. Let's copy this and let's pass the subscription ID. And then the tenant ID. Again, for tenant ID, you can go back and go to the service. Tenant ID, you can get it from here, or you can again go back to the app registration. All applications, select this application that we created and grab the tenant ID. And let's add it. Okay, so we have added this secret and update the secret. Now what we have done is, okay, it is asking me to validate. Let me verify it through my authenticator app. Now as we have updated the secret, let's come back. So this part is done. Azure credentials we have added. What we have done is we have used a service principal. Now that service principal is going to connect our GitHub to the ACR, to the AKS, whatever services, cloud services where we need to connect to. And why this particular GitHub needs to connect there? Because it needs to push the image to the ACR. And that's where our next step is login to the ACR, where we are using this command ACR login. If you remember in the previous document, we have use the same command. So if you see ACR login hyphen name and the service name. So same way we are going to do it, but in this way, now we are not using the direct name, but we are using the application secret. And if you see, this is the secret name that we need to create. Now you can copy this and you can again go back to your secrets, and here you can click on new repository secret, add that. It's ACR name, so you can go ahead and click on it and you can pick the ACR name. So I have already added it. So the ACR name, again you can pick it from the ACR service that we have created. So under the resource group you will get all the services. So this is our ACR and this is the name of ACR. So you can copy this name and you can pass it here, and that's how you can update the secrets. Okay, now again come back. The next step is we need to connect to the Docker. So if you see, first Docker login to ACR. Now this GitHub we have given permission to connect to the ACR, but now we want our Docker to connect to the ACR so that Docker can push the changes. And again, that also we have seen here. So if you see Docker login, the same command we are following here in this, where we need to use Docker login. Now ACR login server that we need to define. So this is the server value that we have, which is nothing but where our ACR service is available. Then the ACR username and password. So if you remember, we have pulled the ACR username and password. So again, you can get those details. You can go to the ACR service, and from the ACR service, so if you open the settings and access keys, from here you will get this password. This is the username, right? So those details we have added. And login server, you can again get it from here. You can see login server. So that I have already added it onto the GitHub. So if I want to show you, so ACR name I have added, ACR login server I have added, ACR password and username. I have added those 4 secrets. You can also go ahead and add those secrets. Now the next step is we need to build an Docker image, where actually we are going to build the image. Now the next part is to build the image. So if you see, name is build a Docker image, and I will show you these names are visible once we run the file, right? Workflow. You will be able to see these names available there. So the command is docker build -t and the ACR login server, and this is our latest tag. So this login server already we have added it, so it will pick it from there. Now this particular file is going to pull these secrets from the GitHub secret. Okay, this part is done. Next is pushing the Docker image. Again, it is pretty simple. We just need to push it. So push Docker image, Docker push, and this is the login server, and in int this is the image that we are pushing it. So with this, it is pushing this particular image to the ACR. Now the next part is we need to connect to the AKS service, and in order to connect to that, we are using name get AKS credential, run az AKS get credential. So if you see, same things that we are following. So this push is done. Now we are creating easy get credentials. If you see, connecting to the AKS, same step that we are following. And again, you can follow this document along where it is. Let me show you. Now push Docker image is done. Now AKS credential. This is in order to connect to the GitHub action. This is basically in order to connect GitHub Actions to the AKS clusters, and this command automatically configures your kubectl to communicate with the cluster, right? So that GitHub can run, or this particular workflow can run the kubectl command, and for which we need AKS resource group, AKS cluster name, and those details again you can get it from the AKS service that we have created. I have already added those secrets. So if you see, AKS cluster name I have added, AKS resource group that I have added, and you can go to the AKS service that we have created. This is the service, and this is the resource group and the cluster name, and this is the name of the cluster that you can add. Okay, and same you can see here. If you see, resource group and then the name of the service that we have added. Now again, the next part is, as the with this we are creating the credentials, we are allowing the GitHub to connect to the AKS. Now we can go ahead and deploy the application. Now the deployment is pretty simple. We have already defined the steps to create the deployment, and with this we are just going to call those 2 files. So if you see, the name is deploy application, and we are running kubectl apply -f ks deployment.yaml. So from this folder, use this file. What this file is going to do, this file is going to create the deployment. It is going to basically register this particular ACR. So this AKS is going to connect to this particular ACR, and that's how it is going to connect. And then with this, it is going to serve. It is going to call the service.yaml, and it is going to serve the application on 8000 port. So that's the deployment command. And next two is just to verify whether the deployment is success or not. We can add a restart deployment in order to restart the application post it is deployed, so that it can go ahead and so that we can see the logs as well. So kubectl rollout restart deployment, and then we can verify whether the deployment is running or not. So those two things that we have added in order to make sure the application is up and running. So that's it. Our file is ready, and that's it is required from our side. Once you are done, once you have added this, you are done. Now your application is all set to deploy. You are all set to trigger the CI/CD pipeline. Now, as we have given that the trigger point is CI/CD, the moment I will push this change, it will go ahead and trigger the application. So let's go ahead and push this change. So I'm adding add CI/CD first cut, and let me commit this, and let's push it. Publish the branch. Okay, let's go ahead and check. Let me go to the code. You can see, let me select the branch CI/CD, and okay, if you see add first cut, this is the change that we have pushed, and you can go to the actions, and under actions you will be able to see. Okay, it's not showing under the actions because I think I made one mistake. So there is one small mistake. This should be workflows, then only it will pick it up. Okay, let's go ahead and push the change. Update workflow, let's push it. Let's push the change, and you can ignore the previous deployments that I have tried earlier. But yeah, now if you go to the code and under CI/CD, if you see, yeah, see update workflow, and you see this bar, this dot, it means the deployment is going on. You can click on details, it will take us to the action. So if you see now, it is doing it is running the workflow, set up the job, check out the repository, meaning these two steps it was able to run successfully. Azure login has failed, and we will check. Okay, no subscription found for star star star. Login failed with the error. Double check if the auth type is correct. Okay, let's go ahead and fix this. It does not have the permission, so let's go to the service principal. So this is the service principal that we created. Let's go to the home directory, select your subscription. We will have to grant the permission. So we need to grant the contributor permission. Go to access control, uh, role assignment. Let's click on add role assignment, and let's give the privilege access so that it can go ahead and add the role. So click on privilege administrator, select on contributor, next. It's user group or service principal, that's correct. Select the member. Here let's search. It was ESPN. Yeah, investor intelligence selected. Review and assign. Review and assign, and let's wait. So once this role is given, now that ESPN has all the rights in order to connect to the, it has a contributor right in order to connect to the services that are available. So now let's go ahead and rerun the job. From here you can rerun the job, rerun all the jobs, and rerun it. Now it should work. Let's see. If it fails again, well and good, we'll fix the issues. Okay, it is checking out repository, Azure login. It should work now. Okay, it still failed. So let's check. Okay, so I just re-triggered it. I think it took some time to reflect the changes. So now you can see Azure login is completed. Next, login to the ACR. Login to the ACR is also completed. Login to the Docker, that also completed. And now the job that is running is building the Docker image. So if you see now, it is building the Docker image, and it has used this command docker build -t, the secret that we have added, the ACR service, and the invent latest. Now it is building the Docker image. Okay, let's see what happened. It failed with Python 3.12 Slim. Okay, you may observe this error sometimes because sometimes that particular Docker from where it is pulling the image, that server might not be responding. So in that case, again, you can go ahead and click on rerun all jobs, and it should work. That should not be the problem. Sometimes it happens. So let's wait for it. Let's check the deployment. Okay, it is logging in. Log into the ACR. That's completed. Login. Okay, yeah, you can see now it is building the image. That was just the small glitch. Now you can see it is installing the dependencies as well. You see, these are the dependencies, and then it will push the Docker. Now here, once the Docker image is ready, which is already ready now, and that image is available at this location. Now it will push that image to the ACR. Here it may fail, but yeah, okay. As we have already given the permissions with the help of Docker login, so it is connecting. Now you can see the deploy application fails because this particular KATS deployment.yaml does not exist. Okay, let's check. Deployment.yaml is not exist. Okay, small change. I think it's not YML, it's YAML. So let's rename it. And same, let's rename this. Sorry, my bad. Okay, I've renamed all the files. Let me push the changes. Okay, so CI/CD is again first time it is. So whenever you are doing this activity for first time, it is a painful activity, and we'll have to deal with it because there are chances that your application, there are high chances that the CI/CD will fail. But yeah, once the setup is ready, then it is not an hectic task. It will keep running. Okay, so again, ECR login is going on. It should work. Sorry, Azure login is going on. It should work. Okay, that is succeed. Again, it is building the image. That part is also almost done. It is installing the dependencies. Okay, see. Let's wait. It should go to the deployment, AKS deployment credential. Again, the credential, there are high chances it will fail. And that's where we are going to debug it. And the reason I'm going step by step, right? I'm not fixing all the issues. That way, like you should be aware, okay, what and all issues we get whenever we work on CI/CD. So now it might be a little longer video, but that's fine. Like you will get to know about it. Okay, see, AKS credential is done, deploy application is done, restart deployment, and again it is rolling out. So though here it is saying that the application deployment is successful, but we will have to check. Okay, you can see the deployment is stuck at this particular place. So something is not correct and we will have to check the logs. Now in order to check the log, we can go to the terminal, and if you see this command connect to AKS, we should hit this particular command. Now this way you can connect to the AKS and you can check the deployment status. So let's hit this command. Let me copy the command and let me connect to it. So okay, it has connected to this. Now let's use kubectl get deployments. Okay, you can see the deployment is there, meaning the deployment was successful, and that's what we saw right in the CI/CD. So if you see the deployment, deploying the application was successful, but somehow there is some issue. So let's check kubectl get pods, and you will get the pods. Okay, see the error. So image pull back off, meaning somehow the AKS is not able to pull the image from ACR, and this happens, right? Even though if you have given the permissions for your AKS to connect to the ACR, sometimes it happens, and that's where you need to manually give the permission. And if you remember, we have done this activity one time, so verify AKS access, and here, yeah, if you see this command that we used, create image pool secret, so we will have to create a secret Kubernetes secrets, and we need to patch that secret so that it can pull the image through username and password. So if you have followed the last video, you will understand the steps. Now let's go ahead and do that. So first of all, let's fetch the credentials that are available, and you can get those credentials from the container registry as well. So same username and password, either you can get it from here or you can go to the container registry, and from container registry you can go to the access keys, and from here you can get the username and password. That's fine. And then you need to run this command. So I'm copying it, and let's run this command. First of all, let's pass the password. So I'm just passing the password. Then let me remove these extra lines. Username is this, that's correct. Then Docker server is also correct. And ACR secret is also correct. Let's click on this. Now with this, you can see the server secret has created, and in order to check that, again you can use the command kubectl. So let's read the command kubectl get secrets, and you should see a secret that is created. Okay, you can see ACR secret is the one that we have created. Now this secret should be able to pull the ACR image. Now again we will have to go ahead and basically restart the deployment. But before that, make sure you are creating a patch. So with the help of this command, you can create the patch kubectl patch service account. Let's go ahead and hit enter. Now this will create a patch, and again if you see, okay, the service is available. So let's go ahead and you can go back and rerun the deployment. Anyway, the build has failed. So let's go ahead and rerun all the jobs. Now with this, it should go ahead and pull the image that is available. So let's see. And again, if it fails, we will fix the issues. But yeah, let's focus on it. So again, Azure login to ACR, Docker image, build Docker image. Everything is working fine. Now it should push the image. Okay, it is pushing the image. Then let's see if it can connect to the AKS. Okay, the deployment is there. Now let's go ahead and check it. Again, I'm coming back to the VS Code, and let's check kubectl get deployments, and it is ready. So kubectl get pods. Okay, it is still creating the container, and this was the last container. So let's go ahead and run it again. It is still creating the container. Create container config error. Okay, let's check. Okay, let's check the log. What's the issue? Sorry, kubectl logs -f and the pod name, and let's see. Okay, error from server container in int in pod is waiting to start or create container config error. Yeah, okay. So I think this part is creating the issue because we have not added the secrets yet. Because I wanted to show you without adding the secret how the application fails. So let me remove this for now. Let's save this file. Let me push it. Basically, I wanted to show you like post which again we are going to add it, but I just wanted to show you like how the pipeline, even though the deployment is successful, your application will not work because you have not added the secret, and how to pull those secrets and all. That's where I wanted to show you, but that's fine. Let's go ahead and check the deployment now again. Yeah, remove secret. Let's wait for this. So let's see now. Ideally it should work now, but let's wait. If it is not, then we will add the secrets and then we will again run it. And again, that's how it happens whenever you are working in the industry. You will have to keep following up. You will have to keep fixing the errors one by one. Even though you have the files ready, everything standards available, but these issues always comes. So, and even industry, more issues come because again from the uh, permission sides, right? You may not have the you might not always have the right permissions to add these contributor access and everything, and you need to reach out to the different teams. So that's where it is a bit hectic task at the first, but once the pipeline is set up, then you don't need to worry about it. So let's see now how it goes. So it's deploying the application, and okay, let's go ahead and check it out now. Get deployments, get pods, container creating. Okay, it is still creating the container. We'll keep checking. A container creation may take some time, so let's wait for it. Okay, now finally the container is running. So this is the container that is running. So let's go ahead and use, and let's see kubectl logs -f and logs at this particular pod. Okay, you can see the application is running. It is starting the application, and boom, we started getting the error. Now From the deployment perspective, we have fixed all the issues. Now the issues are related to your code. So let's see what's the issue. Uh, this particular PostgreSQL, it is not able to connect and no such file or directory. Now why this error is coming? Because we have not added the secrets. So I removed that one block, right? What we need to do is we need to add the secrets. So whatever dot environment file that we have, we need to add all those environment variables onto the GitHub secret. So let me go ahead and quickly show you that. So this is our env file. All these information at the time of the first deployment, right, the manual deployment, we push this file along with the image. But now we are not pushing this file because I have added git ignore file here. So if you see under git ignore, I'm removing all the environment related configs, and that's where under the cicd repository, okay, you can see the build is success. This is the first build which is success. So under this you will not find the .unv file, and that's the standard practice, and that's where we need to add the secrets. Now you can go to the settings and all those secrets you will have to add it. So click on secrets and variable actions. I have already added it. Now you can open that, like from the env, copy, let's say open API endpoint, click on new repository secret, add the secret name and its secret value from this particular env. So you need to go ahead and add the secrets for all these files. Okay, now okay, this is fine. Now I have already added. So if you see, I have added a secrets related to the Azure OpenAI embedding, Azure OpenAPI key, OpenAPI version, chat deployment. All the secrets I have already added it. Postgre user, Postgre port, password, everything is there. Now what we need to do is we need to include these secrets into the YAML. So again, you can go to this deployment file, and here let's add back our environment. Okay, so you remember from here we removed it. Let's add it back. It is going to create this secret, but now we need to create the secrets. It is just going to create a environment name as in secret, but we need to define the secrets on this file, and that definition is pretty simple. We just need to go ahead and pass all the secrets. So I'm creating one more name, one more step here. So once the Docker building is done, once the image push is done, and once you are getting the AKS, this one before deployment, you can go ahead and add it. Now if you see, we have added these many secrets. Let me close this. So if you see, create Kubernetes secrets, kubectl create secret generic in secret, it is going to create this secret. That's what we have defined it in the deployment.yaml file under the K8 Kubernetes cluster, and then from literal Azure OpenAPI endpoint, and then it is going to pick the secret from the GitHub secret. So this is the standard way of reading the secrets, and then we are applying it these particular secrets. So this YAML dot deployment.yaml is going to make sure that it is going to read the secrets from this environment form, and this deploy.yaml is going to make sure it is going to push the secrets into that. So let's save these files and let's push the changes, and now you should see the application up and running. So add env secrets, let's add it and commit it. Let's sync the changes and it should trigger the workflow. Let's go to the code, select the branch. Okay, you can see it's running the job. Let's open it. Okay, it is going on. So let's wait for the CI/CD to complete. Now I don't think we'll face any issues. We should be able to see the application up and running. Let's wait. Okay, deploying the application, it's done, verifying it. So let's wait for the verification. Okay, verified successfully. Okay, all done. Okay, green, meaning it is the deployment is successful. Now let's go ahead and check it here again. Let's go ahead and use kubectl get pods. Now this is the pod that is running, and let's check the logs. Kubectl logs -f, that's full logs and the pod. Okay, you can see the application is running now. Ubicon running at 8,000 ports. Now this is the port on which the application is running within a container. Now we need to expose the application, and in order to expose the application, you will have to run the service command, but that service command we have already mentioned here. So if you see under this service command, we have already given the detail in order to expose the application to the port 80. Now what we need to do is we need to see where this application is running, and to identify that you can again terminate this and you can check the service. So kubectl get svc, which will give you the service on which it is exposed. So if you see, this application is available on this external IP 172.170.59.15, or you can go to the Kubernetes on your service, and from here you can go to the service and ingress, and here you will be able to see the service that is available. So if you see in int, it is available on this port, and from here you can open it, and now it should load the application for us. So let's see. Cool. We are able to deploy the application with the help of CI/CD. Everything is working. Now it is saying no corporate data available because we don't have anything on the uh, PostgreSQL. So let's go ahead and ingest one file. So I'm ingesting Apple file. Now let's go ahead and check out the logs. So in order to check the logs, again go back to the pod, and here you can see the logs. Okay, the financial table was not available. It has created that. The index was not available. It has created the index. So it's working fine. So it is going ahead and creating whatever is not available, and it will go ahead and upload the document. So cool, the application is working. Now let's wait for the PDF to complete. Okay, so you can see it has extracted the key matrices. It has done the it has uploaded the chunks to the vector store, retrieve this content. Let's go to the user interface and check. Okay, you can see the Apple information is available now. Let me refresh it. Okay, cool. Meaning the application is working. All the details are working properly now. And let's test the chatbot as well. And I'm selecting Apple as a company. Let's see. So this should also go ahead and hit to the vector store, retrieve the content and give the response back. Okay, so it's also working. So all the details are working now. Now the thing is, uh, let's see how we will be changing few things on the user interface, and we'll see whether it is reflecting those changes and whether this automation is working or not, CI/CD is working or not. So let's go to the code, and let me close this everything. And now we will just make one change. Let's go to the template file, and on HTML we will change few things. So yeah, this is the iTech logo text, right? So here let's add iTech, and let me add my name. Now this change, let's consider this as one of the feature that we have worked on and we want to push it. One more thing that we will do is under deploy.yaml, instead of CI/CD, let's change it to main. So whenever we push this change, the branch, the CI/CD will only be triggered once the change is pushed to the main. So let's push these two changes, and logo change, and let's click on add, submit. Let's push it. Now it will not trigger the CI/CD because we have changed the branch. So if you go to the workflows and go to the code, so if you see CI/CD has pushed the recent change, and if you go here, it will not trigger. If you see, it has not triggered anything. Under actions, if you go ahead and check, you will not see any workflow that has triggered. Now, as a standard practice, once you push your changes, now this is my feature branch, I have pushed the changes. Now I will go ahead and create a pull request. And once I merge the pull request to the main, then it will go ahead and trigger the CI/CD. So here, let's say logo change. I'm just keeping it simple. Create pull request, and let me merge the pull request. Confirm merge. Now this will merge the changes from CI/CD to the main, and now it will go ahead and trigger the workflow. The moment we do that, it will go ahead and trigger the workflow. Let's see. Okay, you can see merge pull request and it has triggered the CI/CD. So let's go ahead and check now. Again, it is building and all the things are happening. So that's how in the real industry, right? Whenever you push your changes to the main branch, then it triggered the CI/CD, and now it should go ahead and deploy the application. And currently we can see only iTech here. It should start showing my name as well in front of it. Again, just I wanted to show you how these feature development works. So let it run. Okay, deployment is done. It is verifying the rollout. Let's wait for it, because again it takes some time to start the application. So let it restart it first. Okay, it's done. Let's go ahead and refresh the application. Now it should show my name in front of this. Let's see. It's taking time. Let's hold on, because the pod is still getting spun up. Okay, so it has failed because the pod might not have started. Let's go ahead and check it. Let's get the pods. This is the pod that is running, and let's kubectl logs -f and pod. Okay, yeah, okay. If you see, it is showing the name in front of iTech, meaning we have successfully rolled out the feature. So that's how the application deployment works. I hope this was helpful for you. I know it was a pretty long series, but yeah, we have deep dive into each and every minor details, and we have understood this process. We have understood the kubectl commands. We have done the manual deployment, and then we have done these deployment with the help of CI/CD. So this CI/CD is now completely available, and I would highly recommend go ahead and try it out, create these subscriptions and everything, and try this particular project. And don't forget to mention this project into your resume, and please do let me know if this helps you in cracking the interview as well. So yeah, in the next video I will cover the standard practices that we should follow in the industry, and what are the things that we have missed as part of this application, like what and all details that we could not capture, but those are the very important details that you need to consider while working on the industry. So though it be from the security perspective, though it be from the access perspective of the application, and many more, right? And also I got the request to understand which tools we are using, so that as well I will cover in order to design the architecture and all what and all details that we use. So in the final episode, now we will be talking about what and all things that we have missed while building this particular application. Rather, I can say what are the improvements that we can do on top of the application that we have built. So let's get started. Let's go ahead and do a quick recap of the series that we have built. So first of all, from the architecture perspective, like we have started with the architecture, and in which we have built an end-to-end architecture design. And for designing this application, we have used the tools called draw.io, which is a very famous tool available in order to draw your architecture diagram, or you can use another tool called Excalidraw you can use in order to again plot the logical architecture diagram. So I specifically used draw.io in order to build the physical architecture, and Excalidraw in order to build a logical architecture. Then we have built an modular fast API backend application. Then we have built an Postgre metadata and persistent database system. Then from the AI and search perspective, we have used Azure OpenAI to feed an LLM capability. Then we have used Azure AI Search as a vector store. From the containerization perspective, we have used Docker in order to containerize the application, and ACR in order to store the image. And from the deployment perspective, we have used a CI/CD GitHub action in order to trigger the automated workflow, and we have deployed it using a Azure Kubernetes service. And at the end, we have built an end-to-end CI/CD pipeline as well. Yeah, so the thought process was to keep the application simple, start and build an end-to-end application starting from the architecture design to building an end-to-end deployment pipeline. So let's see what and all details that we can improve now. So first of all, let's see from the security perspective. Now from the security perspective, currently the application is accessible to all the users in public, right? Now that is not how it works in the organization. In organization, you want to restrict the application usage. And as this is being an AI powered application, you are really concerned about the cost associated with it, right? You don't want the outside people to access your application. And from that perspective, first of all, you will have to think from the user authentication perspective. So we have not built any auth mechanism in the project that we have built, but definitely there is an improvement opportunity where you can enable a Microsoft Entra ID, that is Azure Active Directory. Now, so as we have used Azure in order to build the all resources, and all the application is built on Azure Cloud, so I'll stick to Azure Cloud related services as well. So for the user authentication, definitely you can use Azure Active Directory, which gives us the feasibility, or which helps us understand who are the users available in the organization and what are their roles, email IDs. So that information we can get it from the Azure Active Directory. Then second one is the single sign-on. Now single sign-on is basically, let's say in your organization you might be maintaining multiple passwords, right? Let's say you have one password in order to log into the email, another password to log into the Teams, for example, to log into your Jira application and whatnot. What this single sign-on application does, it gives a visibility with one password you can log into multiple applications. So you can use your email ID and the same password with which you can connect to the multiple applications. So you can enable that single sign-on. And again, there are ways with which you can enable it. On Microsoft, we have ways in order to enable these single sign-ons. You can integrate that. Then from enhancing the security perspective, you can enable a multi-factor authentication, which gives a extra protection layer. Through this multi-factor authentication, you can send an OTP before login into the application. So that's how you can enable the MFA as well. And at the last, that is a role-based access control again, which is very much important. So currently, if you can go to the application and see, let's say this particular part where we are ingesting the report. Now, if you want only managers to access this particular upload option, then you can add role-based access control. If manager is logging in, then only you can show this particular ingest report option to the managers. If normal users are logging in, then you can only show these particular rest of the features and chatbot options, something like that. So with this, you grant access for the super users who can perform some actions. Like, let's say if you want one particular super users to delete these records, then you grant those permissions, like only super users will be able to delete the records. So that's how the role-based level access is managed through this RBAC. Then comes to the secret management. Now currently whatever API keys, connection details that we have used, we are storing those details onto the GitHub secrets or into the environment files. In the real industry, we follow a key vaults. Like on Azure, we have a Azure Key Vault, which is a very good service, which is a central management service in order to store all your secrets. Now you can create a single key vault in order to store all your project secret. You can add all the project secrets into that key vault, or you can add the secrets from multiple projects as well. And if two projects are sharing some of the common secrets, you can maintain those on the centralized management key vault. And also you can enable a secret rotation policies, meaning you can add a secret expiry after, let's say, 6 months or a year, so that after that time frame, right, you can go ahead and renew the secrets in order to maintain the security standards. The next one is the manage identity. Now manage identity, so what happened is currently we have used the username and password in order to connect to the systems. Also we have used API keys in order to connect to our embedding model, connect to our OpenAI GPT-5 model. But what happens in real industry, we don't use key based authentication, because by mistake if someone push the key into the GitHub, right, that key will be exposed. And you don't want that. You don't want the other users to access the applications through these keys, and there are a security breach that can happen easily. And in order to avoid that, we use manage identity, which is a password less authentication, and it reduces the risk of attacks as well. So how it works is, manage identity, for example, we have two services created, ACR and AKS. Now what happens, our AKS service talk to the ACR in order to pull the image, right? And we have used username and password in order to pull this particular image. So for that username and password, we have given access to pull and push the image basically. But in real industry, what happens, instead we enable manage identity. That way what happens, right, this AKS hits the request to the ACR in order to pull the image, and then ACR identifies, okay, AKS is one of the application which is trying to access who is trying to pull the image. Now who is this AKS? It knows that, okay, through manage identity, okay, this is the application which is built on the same tenant. It gets that detail information. It is hosted on the same platform. It is hosted on the same network. So it identifies the network configuration of these applications, and through this manage identity we can define the permissions. Okay, if this AKS is coming, then only you give the then only you allow that particular AKS to pull the image. So that way you can increase or enhance your security as well. And at the end comes to the network security. So currently our application is exposed to the public user, right? If you want to expose your application to limited folks, you can add those limited folks under your private endpoints. We call it as virtual network. So with VNet integration, what happens, let's say you have a group of people, let's say 100 people working in your organization, and you want only those 100 people to access the application. Now by means, if any another application gets your application link, let's say that the external user knows the link of your application, they try to access your application, what happens that they are not behind this particular virtual network, so they will not be able to access the application even though they have the link. Only these users they can access the application, and that you can achieve through VPN and all other stuff, right? You can enable that private endpoint. So that is again another a network security policy that you can enable, and that basically restricts the public user, the public user to allow enter into our application, and which builds a zero trust model. In the zero trust model, what happens? You grant several permissions that, okay, if any applications are calling, or if, let's say, zero trust model, meaning, let's say, two services are talking, let's say PostgreSQL is talking to, let's say, for example, backend application, right? So in this case, what happens? You build a zero trust. If backend application is hitting this query, then only you allow and share the details with the backend application. So with those, if there is anyone else apart from the backend application accessing the PostgreSQL, then you block the access. So with this, you can enhance the trust between the application, and you can increase the network policy. Then from the reliability perspective, how you can scale this particular application. So from the reliability perspective, first of all, you should enable a monitoring and observability. Currently that is missing from the application. So from the monitoring perspective, right, you can build your custom dashboard, like you can use Power BI in order to build the dashboard, a Tableau, those services you can use, BI tools you can use in order to build the analytics dashboard, which shows how many users are logging into your application, then what are the queries that they are hitting. You can build a customized dashboard for your managers to review the performance, whoever users are using the application. All those details that you can manage by building a centralized logging dashboard. Then from the application perspective, you can build an application health dashboard, like you can build an APM logs, that application performance monitoring logs. You can use a services like Datadog monitoring in order to capture the logs, or there are other services with which you can check the performance, like you can check what is the compute that is getting used, right? Then what are the how many users are hitting the request, what is the traffic coming to your application. So you can check all those details on the application health kind of dashboards, so that you can build. Then comes to the Kubernetes scalability. So currently we have a fixed size of nodes and fixed size of pods. So we created two nodes, right, in this application. So we created node 1 and node 2. Now in these node 1 and node 2, let's say we have only two pods created, P1 and P2. So what happens? Horizontal pod, meaning in a horizontal pod scaling, let's say 100 users are accessing the application, and P1 is sufficient to handle a load of 100 users. Now let's say your user persona has increased to 150. So in this case, what will happen? In the horizontal scaling, it will spin up a new pod, and your new pod will go ahead and serve the user. So the extra 50 users that are coming in, right, those will go to the P2, and 100 users will keep serving from the P1. So that's how you can increase the pods. Now, then the cluster auto scaling is, let's say you have reached the limit. Let's say this particular node 1 is having a capability to serve only 200 users, and you receive 201st users. So that first user will be redirected to the new node, and here again you will have P1 and P2 kind of pods. So this will start consuming from the P1. So whenever the moment you shift to create a new cluster, that's what it's called, a auto scaling cluster. So here, node 1 and node 2 are nothing but you can consider them as a VM, which provides the compute power. So you can build a completely new compute power. Let's say if this is 16 GB machine, and which is sufficient to serve 200 users, and if you get new request, you again build another 16 GB machine in order to serve the new user. And that's how the auto scaling happens, right? So if we take an example of a cricket match again, so let's say if 1 million users are watching, let's say, IPL on Jio Hotstar, right? So what happens on the application? It will serve the users, but the moment the match, these users are, let's say, so these viewers are before starting the match. Let's say if actual match starts, then that number can go to, let's say, 4 million. And in that case, you want your sustainable application which can automatically scale up and keep serving the new users. So for those reasons, we need to work on the Kubernetes scalability, and you can enable the auto scaling. So that part also you can integrate into the application. Then comes to the disaster recovery. You need to think from the disaster recovery perspective as well. What happens by mistake someone deletes the database? So you should have an backup data set available which can keep serving the user even though something bad happens to your database. And you should build an automated recovery strategies as well. The moment you see some issues, you should pull the data from the backup that where you are storing in. And also you can enable a multi-region deployment with high availability architecture, meaning you should not deploy all your application, let's say, on East US, right? If anything goes wrong, you should have another this particular East US is, let's say, serving the particular region 1 users. Then you should have another cloud region from where you can search to the region 2. That way it gives visibility, even though if the region 1 is down, your region 2 can keep serving. So that's how you can build an high scalable architecture as well. Moving ahead, how you can think from the expanding the application beyond RAG application. So you can enable an advanced architecture by integrating a multi-agent framework. You can increase the capabilities. Also, you can build an agent orchestration framework along with. From the AI governance perspective, we have not added any guardrails. Whatever question that user is asking, right, prompting into the chat, we are directly hitting that to the GPT-5 model, but you should add some guardrails as well. Like the model should only generate the response related to the investor related questions, right? It should not generalize, give answers to the generalized question. So you can add those guardrails. Basically, you can add a responsible AI controls as well. It should not generate any harmful content. So those things you can manage from the AI governance perspective. So whenever you work on the real industry project, right, you need to think from these perspective as well. Whenever you are building the application, you will have to actually add these guardrails. You will have to perform intensive testing that your application should not generate any harmful content, and all those things that you need to make sure. Apart from that, you need to control the cost as well. Let's say if your 100 users are accessing the application and the cost is, let's say, $100 a month. So you will have to think from, let's say, if the number of users are increasing, your cost will also increase, and how you can manage that cost, how you can keep tracking those costs. You should add some threshold. That cost should not go beyond that threshold based on your budget allocated to your project and all that stuff, right? So those, from that perspective also, we think whenever we are building an actual application. From data engineering perspective, so currently we are, whenever user is uploading the PDF, we are directly retrieving the content and storing that into the vector store, but we don't have any intermediate storage. Ideally, we should have one intermediate storage to keep that particular file, maybe a temporary, a volatile storage, so that if anything goes wrong in the vectorization, right, you can again pull back that particular PDF file. Then comes to the DevOps platform. You can build an multiple pool of environments. So currently we have just built one environment, but ideally in the industry we follow a multi environment deployment approach, right? Like you follow dev, testing, production, like this. You can build the multiple environments, and again it varies based on the project. Some environment follow 3 standard deployments, some follow 4, and it varies. And accordingly then you can work on later on the incremental deployment as well. So those are the some things that you can improve from the architecture perspective as well. And coming to the last, the key learnings that we have obtained out of this particular course is, first we have learned the AI and RAG fundamentals. We have understood the retrieval-augmented generation, the OpenAI, and the resources that are required in order to build the RAG application. Then comes to the cloud native deployment. So we have built the deployment using fast API backend. So now we are aware about the fast API backend as well. Then we have Dockerized the application. So we have gain understanding on Docker containerization. We have built our own Docker image. Then we have stored that image on the container registry. So we have understood the resource from Azure, that is ACR. And finally, we have deployed the application on AKS, which is a deployment service. And then also we have built an CI/CD pipeline. So we have gained this particular knowledge as well, how GitHub Action works, how to automate the workflows, and how the production deployment, what are the production fundamental deployments, that also we understood. And we have built an end-to-end CI/CD pipeline. So those are the things now we have mastered in, and these things are really going to help us in building further projects as well. So that's it for this particular series. So with this, I'm concluding this project series, and I hope you enjoy this particular series. I hope you have watched the previous videos as well. If you have missed, I would highly recommend to go ahead and check out that. Please feel free to share this series with your friends, and also if you want, you can add these particular projects into your resume. All these content, all these notes and everything is already available on my GitHub. You can check that link in the description. I have uploaded all the documents, all the code, everything, notes, everything is already uploaded. So yeah, please go ahead and hit a like, subscribe to our channel iTech, and if you are interested in more such videos, please do let me know in the comment section what next project series I should capture, what are the cloud technologies I should cover, and what are the other AI application I should be focusing on building. So with this, let's end this particular series. Thank you for watching this series, and see you soon in the next interesting series.